We'll wait a moment for others to join the stream. A cool thing today is that I'm on Windows and I have a Linux terminal installed. So I think from now on I will only use Windows on my streams and videos, and I can still work efficiently with this terminal. There will be some issues, I guess. This is not very well supported, but should be fine. So I must open Restream chat. Here we go. And a little bit more of setup. I must also remember to change the description on Twitch. Hello, Varun. So Twitch description, not here, here. Today I'm going to continue the research that I did a little bit in the last stream. I want to check out materials online to different tutorials, and okay, the time is okay. Maybe I can remove that for now. Okay, let's refresh. In particular, I might read some part of the Competitive Programmer's Handbook that I often recommend people, and still I only just once went through some very first part. Hello, No Moniker, welcome back to the stream. As usual, we are both on YouTube and Twitch, and later you can watch the video on YouTube. What about G++ on Windows? I don't understand your question. Oh, you mean why do I need terminal at all? Because this way I can move efficiently and work with files, while I don't know how to do that in Windows. And hello, Muxe. Okay. Previously, I went through segment trees tutorials and Gaussian elimination. There were some issues. So with Gaussian elimination, one explanation was good in theory, but not in competitive programming, while the other lacked, I think, the example. So Emacs, English translation of Emacs was fine, but there was no explanation of algorithms, so it would be hard for someone who doesn't know Gaussian elimination. It's good for competitive programmers who want to read how to implement that, I guess. What I didn't do is I didn't check how is it explained in this book, what I'm going to do today. Hello, Vangster. So it's 10:05, we can start. If somebody is new here, I'm Errichto, and my channel is about algorithms, competitive programming, and welcome to boring programming stream number 5. I think we can start by checking out at least the list of topics here. Of course, as I said, this is boring programming stream. Don't be surprised if there will be nothing interesting for the next few hours. Mainly I will just check and read different materials today to see what is nicely explained and what I can recommend to people. So we have introduction, maths, working with numbers, so long type, modular, doing operations modulo, floating numbers, shorter code, so defines, simple maths, the definition of sets, union, intersection, basics. What do we have next? Time complexity, sorting, binary search, sorting theory. I would say that binary search is easier than sorting. I know a good story, by the way, about sorting. Not about sorting, about binary search. There was a like TV tournament or show in Poland that where you were supposed to guess something in 20 questions about it, and the answer could be only yes or no. So people ask questions like, I don't know, is it metal? Is it everyday use object? Something like that. And 3 guys from, I think, University of Warsaw came with a dictionary, because the rule was this word is guaranteed to be in the dictionary, and it was allowed to have a dictionary. So they had a dictionary and they binary searched the answer. They opened the book in the middle, found a word like, I don't know, M whatever, what is in the very middle of the book, and asked whether this is lexicographically smaller or greater than this word, or whether it's later than this word in the dictionary. So since the number of words in dictionary is much smaller than 2 to the 20, and they were allowed 20 questions, they easily won, like, I don't know, 15 questions, and the show was cancelled. I think it's stupid that the show was cancelled. They should have just forbidden to use dictionary, I think. But maybe still people would ask questions like, is the first letter before or after K? So it's hard to forbid that. How did your hash code go? You can read about it in Code Forces, or you can see the leaderboard. I was 23rd, what I think is enough to qualify. Hello Errichto, hello Jatin Sharma. Okay, let's go through this. So the author is from Finland. I think he works in the university, and he published this free PDF like a year ago. It looks very nice, and it is really for competitive programmers, while other books are about, for example, algorithms, but they will not say anything about how to use something, create something in competitive programming. We have some special stuff in our contests, what is important to understand. The purpose of this book is to give you a thorough introduction to competitive programming. It is assumed that you already know the basics of programming, but no previous background in competitive programming is needed. The book is especially intended for students who want to learn algorithms and possibly participate in the International Olympiad in Informatics, or in the International Yeah, ICPC. Of course, the book is also suitable for anybody else interested in competitive programming. Hello, Sanjay. It takes a long time to become a good competitive programmer, but it is also an opportunity to learn a lot. You can be sure that you will get a good general understanding of algorithms if you spend time reading the book, solving problems and taking part in contests. The book is under continuous development. You can always send feedback on the book to my email address. Helsinki, July 2018. Until Laksonen. Hello, Nojae. By the way, if you haven't, after the stream, go check out my video about Codeforce's diff1d problem isolation from around 1 week ago. So this is this time a harder problem. Previously, I tried to choose something that will be possible to understand for like, people without background. So this time I tried a hard problem. I hope still many people which will watch that and gain something from it. Hello Shahbaz, hello Mohammed. Hi everybody. Okay, we have part 1, basic techniques. Okay, where was the list? Okay, let's go through it quickly. We need design of algorithms and implementation of algorithms. Statistics of languages. In CodeJam, in 3000 best participants, 79% used C++. The programs follow the C++ 11 standard. Let's see how he explains the magical lines, like include. Usually when you teach someone programming, in the first lesson you just say, okay, you must put these lines and you shouldn't understand those. Just always put main include using and you will eventually know what they mean. Okay. Compilation flag. This produces a binary file test from the source code test CPP. Read we've seen, cout, output we've see out. Or scanf and print. Yeah, I think that seen and see out are easier to understand and like easier to read for beginners, so it's better to use them in tutorials. Input and output are sometimes a bottleneck in the program. The following lines at the beginning of the code make input and output more efficient. Note that the new line works faster than handle because ENDL always causes a flash operation. Scanf and print are an alternative. Read the whole line. And you can read from file and write to file. Yep. Working with numbers. Is the stream over? Is something wrong with the stream? It's so why do you ask if is the stream over? Maybe something is wrong with my connection. But I see the stream working on the laptop. Okay, The most used integer type is int. If int is not enough, then use long. You can use long this way. And you can overflow. Yeah, those are important stuff to learn at the beginning. On the other hand, maybe first when you're really new to programming, competitive programming, maybe stuff like overflows should be left for later. And first you should solve some very easy problems, like just try to use print and ifs to like read a number and say if it's even or odd, stuff like that. Maybe overflows should be covered later because now it's unnecessary. And I would say it's a bit scary. It's fine, okay. Modular arithmetic. We denote by x mod m the remainder when x is divided by m. The answer to the problem is okay. I think a very good example is compute n factorial for given n up to 1 million, where the answer would be huge, but you can write L for loop from 1 to n, multiplying by I and taking modulo m. I think that should be given as an example. Maybe I should write down those stuff. Maybe some of this would be so it is said that this book is still in the development, so maybe if I write down some notes and send it to the author, maybe those will be considered. This is competitive programmers. By the way, until yesterday, I always thought it's competitive programming's handbook, or just even without S, what is incorrect. It's competitive programmers handbook. It often delays a few seconds, like your stream is over. Okay. My internet connection and CPU power should be fine, so I don't think that's my mistake. Like I should do something wrong. There is some problem. So what problem is there? Let's how can I check it? So on my laptop on the site I see both Twitch and YouTube open. I don't see any lagging or loading. The audio is turned off, so if something will be wrong with audio, you must tell me in chat. Yeah, so if you will tell me what exactly is wrong, because I don't understand that from No Moniker's explanation. It often delays a few seconds, like your stream is over. So it's a black screen. I don't see anything like that on my laptop. Overflows. Cover overflows later. What problem? Yep, I also don't get the problem. Cover overflows later. For modulo, give the example of factorials. Oh, okay, I'm stupid. Just after this, the example of with factorials is given. Okay. Okay, what about this? If the result can be negative, we should add let me just read this. Yes, there is some problem. Okay, but what problem exactly? An important property of the remainder is that in addition, subtraction, and multiplication, the remainder can be taken before the operation. Thus, we can take the remainder after every operation, and the numbers will never become too large. Well, for example, the following code calculates n factorial modulo m. Well, here modulo m is unnecessary if you take modulo m every time. Unless modulo is 1. This is a very tricky thing. We want the remainder to always be between 0 and m minus 1. The remainder of a negative number is either 0 or negative. An easy way to make sure there are no negative reminders is to first calculate the remainder as usual and then add m if the result is negative. However, this is only needed when there are subtractions in the code and the remainder may become negative. Double is enough, long double is more accurate. The following code prints the value of x with 9 decimal places, that's true. But this is code for floats. If we recommend won't I get so let's see. I think I will get a warning if I use it like that. Yep. Just a type. It's fine. So I always use elef. So I think that this is casted to float first. Let's check. Let's make something that is not non-integer and print it with huge precision. Maybe with bigger precision. Why does string keep on refreshing after some time? Well, if you have some issues, you can go to Twitch, because I stream the same thing there. Let me check my connection, but I don't think the problem is on my side. I hope I will not mess something up by running this speed test. Like ping is small. No refreshes on Twitch. If you have big issues in YouTube, switch to Twitch. The link will be in the description, or Twitch TV/Errichto. Yeah, everything is fine here. So maybe something wrong with YouTube. I didn't change my encoder settings since the last stream, so I don't think there's something that I did wrong. Okay, switched. Yeah, you can always you can also open 2 tabs, just like I did in my laptop. So this is what I have in a laptop on the side, both YouTube and Twitch. Okay, so what about this? Why is everything working here? Hello, Karim. So apparently this is equivalent. Everything happens in the same way. I mean, the printed value is the same for LF and for F. But I think this is still bad. So no, I didn't get any warning. What about using LF? Big uppercase L. So this is long double is expected. Maybe %F is just for both float and double. I don't know. Are you using Bash on Ubuntu on Windows? Yes, I do. So today in the morning I installed like Linux terminal on Windows, and now I can just stick to Windows and use everything here. Difficulty when using floating point numbers is that some numbers cannot be represented accurately as floating point numbers, and there will be rounding errors. For example, the result of the following code is surprising. Okay, let me run this code. Oh, I didn't copy it. There might be some issues, for example, with pasting something here because it's like emulation. Yeah, so here I have to, well, did I copy at all? No, I didn't. So there's an issue with copying from this page. Okay, now it's copied. Let's try that. Indeed, it's 0.999 and so on. Why I switched from Ubuntu? Because the streaming software for Windows is better, and also software for drawing. The OneNote is very nice to use. Generally, Windows is better supported because more people use it. So because of drawings and streaming software, I would prefer to do things on Windows. Due to a rounding error, the value of x is a bit smaller, while the correct value would be 1. It is risky to compare floating point numbers with the equal operator. Okay. While floating point numbers are inaccurate, integers up to a certain limit can still be represented accurately. For example, using double, it is possible to accurately represent all integers whose absolute value is at most 2 to the 53. Yep. I wonder whether it's a good idea to talk about floating, like precision issues, so early on. If somebody starts, it's better to practice some simple stuff with him, like ifs, for loops. On the other hand, this book is for people that already know C++. Not necessarily C++, but some programming. Hello skyscraper, hello Bhaskar. Type names. Okay, typedef. I think that now it's better to use using LL equal long. But maybe I will do this format. Change this to that. Type def long ll using ll is long. Does anyone have problems with the stream going off? If you have problems, then go to Twitch, because everything works fine there. And I stream the same thing. the issue should be either on YouTube site or on the side of the Restream. The question is whether it's so bad on YouTube that I will have multiple files. If the stream stops for a minute, then there will be multiple videos in my channel. What would be bad? Started streaming 30 minutes ago. Okay, I think there is no, fortunately there is no big gap. Starting and ending continuously. Yep, so just switch to Twitch, at least for today. Maybe next time there will be no issue, because I didn't change anything in settings and the last time it was fine. How old am I? 23 or 4. What language is this? C++. So for competitive programming, people usually use C++. And now, if somebody has just joined, I'm just going through, so I know competitive programming a little bit. I just go through the materials to see what is well explained and what should be recommended for beginners. Twitch has quality options today also. Nice. Your stream often keeps refreshing. Golang greater than any. I think there are some advantages of C++ if 90% of pros use C++. Maybe not 90%, 80%. C++ is very fast, that's for sure, and has a lot of libraries useful in competitive programming. Typedef, we can use Typedefs for that. Macros, so defines a little bit, yeah. V pushback. Okay, so this should be changed to in place back. Still, maybe this is not for like per in place back. Why? I don't know the stuff that I'm proposing here on the right. I don't know in what version of C++ it's valid. So the book is for C++ 11. Disagree. Golang can beat C++. Interesting. Golang versus C++ speed or performance. So this is seconds, I guess. Then C++ is always faster in this benchmark. And sometimes faster by a lot. Check out the concurrency. What do you mean? Checking out the concurrency? So this is like, you mean parallel computing for these two languages? Why employees back is preferred? I will explain in a little bit. If it has built-in support. Okay. So they compare Java and C++ because of garbage collector. Question from 2015. Yes, so I should find something more recent. Maybe you can just paste a link, and I think in Twitch you can paste a link. I don't have to like review it. So if you find some materials that I should read, just paste the link. But still, on contests, usually only C++ and Python are allowed, so I will stick to C++. Why in-place back is preferred? Yeah, it's shorter and it can only be faster because it doesn't create object and then copy it. It just creates it on that vector. I tried solving this problem. I tried understanding the tutorial, but was unable to understand the states. Maybe I will check it out later. By the way, when I used pushback, I would use still, I don't know if it's C++ 11 or something later. I would use this. This also works. Compiler understands that this is a pair. Define square root. Yep. Those issues are important to touch. Maths. Maths play an important role in competitive programming, and it is not possible to become a successful competitive programmer without having good math skills. This section discusses some important math concepts and formulas that are needed later in the book. Each sum of the form blah 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 has a closed form formula that is a polynomial of degree k plus 1. For example, a reader doesn't have to know what is a polynomial, I would say. It's standard for someone who studied maths in university, but not for high schoolers. Avoid using a word polynomial in some formulas. But this is, so saying that is fine, especially the first one. The sum of arithmetic progression is important thing. The sum consists of the numbers, and the value of each number is this on average. Geometric progression. Do we need to show here proofs for something like that? For geometric progression. It's unnecessary. Special case is the sum of powers of 2, right? Harmonic sum. An upper bound for harmonic sum is this. Okay, it's not the nearest power of 2. It's you round it up. It's the nearest power of 2 greater. Oh, that does not exceed k. Okay, makes sense. Fine. Do we need to know that formula? No, we don't need to. And this formula, Vollheiber formula, is really complicated. If you are good in competitive programming, then it's useful to also learn complicated stuff. But I don't know this formula. I remember that I needed that for some very hard problem when, I don't know, I wanted to solve it or something, and it was very hard to comprehend that. It isn't often needed, just you can use, if you have the internet access, you can use Wolfram, and generally, and I think some interpolation is more general and will also allow you to compute such a sum. Can you probably use Discord streamer mode to show people on Discord when you're streaming? Okay, what is this? Discord streamer mode. Gives you a quick and easily accessible menu to hide sensitive or personal information when you're in the middle of streaming to your fans. Okay, but this looks like streaming using Discord or what? Like this looks like hiding some stuff in Discord while I stream, like disabling invitations, for example, for some time, but I don't see how it helps with like notifications for you. Okay, harmonic sum is limited like that. Set theory. Intersection of sets is this, union, complement. Difference. Well, for sure, I didn't know such words as intersection and union when I started competitive programming. And I think it isn't very important, but that's fine. A subset. Maybe it's important to understand words because they might appear in the statement. Set of natural numbers, integers, and so on. Logic. By the way, so we have issues today with YouTube apparently. I also see them on laptop, by the way. I anyway thought about switching to Twitch completely because those boring programming streams aren't so important for somebody to watch later. So do I really want them on my YouTube channel to be accessible later? Maybe I will stick to just short videos on YouTube, but then I also do some lectures, like 1 or 2 hour long. And the question is whether I want them on both platforms or just on Twitch and then upload to YouTube. I'm not sure about it. The question for you, chat, does somebody here doesn't want to does somebody here have issues with one platform generally? So if I stream just on Twitch, will some of you cannot watch me because of that? Maybe, for example, Twitch is blocked in some countries, or YouTube. They're better than watching cooking tutorials. Well, for people interested in algo, I'm sure my streams are better than cooking tutorials. Still, maybe those boring streams should be only on Twitch, because it's more about hanging with the audience rather than teaching you something. Okay, the expression, this is the opposite, and predicate. Okay, that's some unnecessary stuff too. No, please, Twitch is blocked in my network. Okay. Interesting. Maybe I will Google today's issue. YouTube stream refreshing every few minutes. Okay, but it's not about the website refreshing. It's about the video refreshing. Or just stopping. Maybe there's, yeah, so right now. How often does it happen? Every minute or what? Oh, it's again 10 seconds. Yeah, it's very frustrating. The only thing I changed is that I installed that Linux terminal, but I don't use it to run OBS. It's still just in Windows. So it shouldn't be an issue. By the way, I wonder, because many people now switched to Twitch, maybe we are high in science technology category. Yeah, here we are. I find YouTube to be terrible for new people to discover anything related to streams. YouTube is about videos, not streams. I think the problem is with YouTube. It happened with some other channel as well. Okay. So then I can do nothing about it. I would say that this maybe move logic to much later in the book. Much later. To be later, maybe. I'm not that good in English. Using the notation described above, we can express many kinds of logical propositions. For example, blah blah. Unless he wants to use that later in the book. Functions. It rounded up, so floor and ceiling. Okay. Say that is floor and the other thing is ceiling. Here he doesn't use word floor, and when later somebody will talk with someone else, or he will read the editorial and it will say take the floor, he will not understand that, so it's important to mention. These functions say that you can use mean of ABC in C++. Did you know that, by the way? Instead of doing minimum of A and B and then taking minimum with C, you can pass in C++ just minimum of this of such a list. It will be understood as a list in modern C++. No, it's better. The factorial is defined recursively, the Fibonacci numbers, Binet's formula. I hope that nobody tries to remember that after reading. Logarithm is denoted. Okay. Logarithm is important for competitive programming because it often appears in complexity. Again, I wouldn't teach that a person in school that starts with competitive programming because it will only scare him. But it's fine in a book, I guess. What are you doing at the moment? Right now I'm reading Competitive Programmer's Handbook. Or the question is, what do you do in your life? Is it possible to calculate algorithm to any base? If there is a way to calculate logarithms to some fixed base. Natural logarithm. Okay. Contests and resources. IOI. There are usually 300 participants from 80 countries. That's a lot. IOI consists of 2 5-hour-long contests. IOI syllabus regulates the topics that may appear in IOI tasks. Yeah, so he mentions Croatian Open Competition in Informatics. Soki, something like that. That is open and has nice materials. You can check it out. And USACO. In addition, a large collection of problems from Polish contests is available online. That's true. ICPC. Annual programming contests for university students. Five hours of time to solve about 10 algorithm problems. A solution to a problem is accepted only if it solves all test cases efficiently. Online contests. There are also many online contests that are open for everybody. At the moment, the most active contest site is Codeforces, which organizes contests about weekly. I think even more frequently than that. In Codeforces, participants are divided into 2 divisions. Beginners compete in Div 2 and more experienced programmers in Div 1. Other contest sites include AdCoder, CS Academy, HackerRank, and TopCoder. Some companies organize online contests with on-site finals. Examples of such are Facebook Hacker Cup, Google CodeJam, and Yandex Algorithm. I'd say that 3 biggest ones are CodeJam, TopCoder Open, and Facebook Hacker Cup. So Yandex is much smaller. Companies also use those contests for recruiting. Performing well in a contest is a good way to prove one's skills. There are already some books, besides this book, that focus on competitive programming and algorithmic problem solving. 1, 2, 3. Yes, looking for a challenge is for much more experienced. No, the first 2 books are intended for beginners, whereas the last book contains advanced material. Of course, general algorithm books are also suitable for competitive programmers. Some popular books are Corman. Yeah, I've read Corman, but I don't recommend it very much right now. It's an old book that also I think is very math heavy. There are so many proofs and boring parts. We need the video on the YouTube later so that we can watch at 2 times speed. We miss it. Okay. Time complexity. That's an important topic. The efficiency is important in competitive programming. The idea is to represent the efficiency as a function whose parameter is the size of the input. By calculating the time complexity, we can find out whether the algorithm is fast enough without implementing it. I think the idea is the goal is to estimate the running time, not really represent as a function, or maybe calculation rules. Usually the variable n denotes the input size. For example, if the input is an array of numbers, n will be the size of the array, and if the input is a string, n will be the length of the string. Loops. Yeah, the k nested loops are indeed n to the k, order of magnitude. Yeah, time complexity does not tell us the constant factor. Mention term constant factor. So n is the O of n is the complexity, while the fact that it will run 3 times for a loop is called the constant factor. Phases. The total complexity is the largest time complexity of a single phase. That's true. As long as those consecutive phases, as long as there are only a finite number of those. If you n times repeat something, that it's not the maximum, it's n times that. For example, the following code consists of 3 phases with time complexities n squared, and thus the total time complexity is n squared. Sometimes we have different stuff in loops. Yeah, this is n times m. Recursion. For example, consider going from n to n minus to n minus 1. Another example, consider the following function. Let us see what happens when g is called with parameter n. The following table shows the function calls produced by this single call. That's true. The time complexity is 2 to the n. Complexity classes. Constant time. Logarithmic time. Square root. I would remove this sentence. A special property of square roots is that square root is n divided by square root, so the square root lies in some sense in the middle of the input. If somebody doesn't understand that, he will gain nothing from it. Remove a special property of square roots is that I understand that it's useful, but if somebody doesn't know that, he will not get that from this explanation. Linear algorithm. And log n. Quadratic algorithm. Cubic. 2 to the n. N factorial. An algorithm is polynomial if its time complexity is at most nk, where k is some constant. Okay, also logarithms are allowed. All the above time complexities except 2 to the n and n factorial are polynomial. In practice, the constant k is usually small, and therefore a polynomial time complexity roughly means that the algorithm is efficient. Well, if the problem says that n is up to 100,000, then n cubic is not that efficient. Most algorithms in this book are polynomial. Still, there are many important problems for which no polynomial algorithm is known. For example, that is, nobody knows how to solve them efficiently. NP-hard problems are an important set of problems for which no polynomial algorithm is known. Estimating efficiency. Yep, that's important. Modern computer can perform some hundreds of millions of operations in a second. For example, assume that the time limit for a problem is 1 second and the input size is 100,000. If the time complexity is n squared, the algorithm will perform about this many operations. This should take at least some tens of seconds, so the algorithm seems to be too slow for solving the problem. On the other hand, given the input size, we can try to guess the required time complexity. Yeah, all of that is reasonable and is large. Yeah. This information makes it easier to design the algorithm because it rules out approaches that would yield an algorithm with a worse time complexity. Constant factors. Okay. So he mentions constant factors much later. Earlier. When we introduce complexity. For example, an algorithm that runs in O of n time may perform n divided by 2 or 5 n operations. This has an important effect on the actual running time of the algorithm. Okay, that's fine. Maximum subarray sum. This section discusses a classic problem that has a straightforward n-cubic solution. It is possible to solve in n square or even O of n. Maximum subarray sum. We assume that an empty subarray is allowed, so the maximum subarray sum is at least 0. Algorithm 1. Go through all possible subarrays, each with linear time. Why? I think it's bad to name variables a and b, and then he has to describe what a and b are. What about naming them first and last, or start and end? Name variables L and R, or start and end instead of A and B. And maybe I will note down the topic, the chapter or subchapter. The variables a and b fix the first and last index of the subarray, and the sum of values is calculated to the variable sum. Best contains the maximum sum found during the search. The time complexity is n-cubic because it consists of 3 nested loops that go through the input. Okay, removing one loop. This is possible by calculating the sum at the same time when the right end of the subarray moves. So, one moment. Okay. This is not a very good explanation of this problem. Maybe it's good for the sake of explaining the complexity. I would just say, if explaining to someone, that here we repeat some computations many times. If we already know that a piece of like the subarray from A to B is 17, then when we expand by 1 to the right, so we add the number at b plus 1, then we just take that 17 and add a new number, constant time. But that's fine. Algorithm 3. Surprisingly, it is possible to solve the problem in O of n time. This linear time algorithm is attributed to Cadan, and the algorithm is sometimes called Cadan's algorithm. The idea is to calculate for each array position the maximum sum of subarray that ends at that position. I think the more straightforward solution, maybe not more straightforward, what I think is easier to understand is that we equivalently we say that we want to remove some prefix and some suffix, and the sum of those values of prefix and suffix chosen should be minimum possible, because what is left in between should be maximum. So some solution is to go to the right, and in the process remember the smallest prefix sum so far and consider that as a candidate. That's also enough. Well, this algorithm is harder to understand and to prove. Consider the subproblem of finding the maximum sum subarray that ends at position k. There are two possibilities. Subarray only contains the element at position k. The subarray consists of a subarray that ends at position k minus 1 followed by the element at position k. Okay, that's fine. The algorithm only contains one loop that goes through the input, so the time complexity is O of n. This is also the best possible time complexity because any algorithm for the problem has to examine all array elements at least once. Efficiency comparison. The following table shows the running times of the above algorithms for different values of n on a modern computer. In each test, the input was generated randomly. The time needed for reading the input was not measured. 0, 0. Maybe this table should be given with more precision after decimal point, because this one should be already like 0.01, let's say. The comparison shows that all algorithms are efficient when the input size is small, but larger inputs bring out remarkable differences in the running times of the algorithms. Algorithm 1 becomes slow when n is 10,000, and algorithm 2 becomes slow when n is 100,000. Only algorithm 3 is able to process even the largest inputs instantly. Chapter 3, sorting. Okay, so how far are we in the book? 34 pages done. What do you have? Generally we have 300 pages. So there will be now sorting, data structures, complete search, greedy algorithms, dynamic programming, amortized, segment trees, bit manipulation. Shouldn't bit manipulation be before binary indexed tree? Because binary indexed tree has some binary operations to make it efficient to implement. Implementation, yeah. So here we have that. I wonder how much time it takes to write such a book. So this is like 1000 hours. I think that's reasonable. Okay, let's continue with sorting. For example, the problem does an array contain 2 equal elements is easy to solve using sorting. Also the problem what is the most frequent element in the array can be solved similarly. There are many algorithms for sorting. The efficient general sorting algorithms. I think CP3 by Stephen Halim is good for beginner. Have you gone through it? No, I haven't. but I can't. So is it available online? Competitive programming, free, Stephen Halim. Ebook is $20. So I haven't. And if it's paid, then I will not go through it in any stream, because then it's copyrighted, I guess. I don't know how the law works, but I think I shouldn't scroll through something that is not free to access. Ebook only. Why can't I click that? CP1 is free, first edition is free, okay. I will quickly check it out, like the table of content at least. Subarray. Introduction. What does a triangle mean? Greedy. Graph, maths, string processing, computational geometry. And it's 150 pages long. As a little practice, try typing this code. Okay, type code faster. I think this is a very bad tip for beginners, because typing code is so much less important than solving problems quickly. It might be even better at the beginning if you code slowly, because then you should think how to do something efficiently, and you should invent a simple approach instead of implementing something random and long because you can type fast. So this shouldn't be the first advice. Quickly identify problem types, do algorithm analysis, master programming languages, master the art of testing code. Practice and more practice. Getting started, ad hoc problems. This should be links. Also, can I just Google that? Like, yes, I think I can. But for practice, I think for practice it's better to solve problems that have editorials. What if someone wants to solve such a problem but it doesn't work? So maybe UVA is not the best place to study. Okay, maybe I will buy the recent edition and will read through it. Thank you for suggestion. Sorting theory. Given an array that contains 10 elements, your task is to sort the elements in increasing order. Well, non-decreasing order, I think. and square algorithms. Bubble sort. Yeah, bubble sort is short, but it's not so easy to understand why it works, I would say. FBI open up. I think it was not a police, it was, how is it called? The ambulance, medical car. After the first round of the algorithm, the largest element will be in the correct position, and in general, after k rounds, the k largest elements will be in the correct position. That's true. So bubble sort is quite fast for... Is it n log n for random arrays? I don't remember. I can check that. Let's start with 1000. While true, anything happens. So I'm writing such a code that it will understand where it should stop. Iterate over everything. If a of I greater than a of I plus 1, anything happened is true, and plus plus, and swap. If not anything happened, print rep to return 0. And this should be a loop over rep. Almost 1000. Oh, of course, because no, because when element goes to the left, it will move at most by 1 in every iteration. Okay, I should have understood that without implementing. So it does need indeed n iterations. The advantage of this approach is that it's quite fast. The constant factor is small because we efficiently iterate through the array. So the usage of cache is nice. Inversions. Bubble sort is an example of a sorting algorithm that always swaps consecutive elements in the array. It turns out that the time complexity of such algorithm is always at least n square. Oh, the complexity of algorithm that will only swap consecutive elements. A useful concept when analyzing sorting algorithms is an inversion, a pair of elements that the left number is greater than the right number. For example, the array has 3 inversions. Is it true? Yep, it is. The number of inversions indicates how much work is needed to sort the array. An array is completely sorted when there are no inversions. On the other hand, if the array elements are in the reverse order, the number of inversions is the largest possible. Swapping a pair of consecutive elements that are in the wrong order removes exactly 1 inversion from the array. Okay, but is it important here? So this is sorting. Should we really prove that swap 2 consecutive must be O of n square? I don't think it's important. Sometimes, I guess sometimes it's good also to remove some parts of a book because they are not necessary. It's better to be concise. I don't know the word. Concise. Okay, this one. Concise. Concise. We can get n log n. One such algorithm is merge sort, blah blah blah, description. Merge sort is an efficient algorithm because it halves the size of the subarray at each step. But it isn't explained how to merge. I think it's much more important than the proof why that previous algorithm must be n square. Explain how to merge. Sorting lower bound. Can we do it faster in n log n time? It turns out that this is not possible when we restrict ourselves to sorting algorithms that are based on comparing array elements. That's true. So I know this proof. But again, is it important in a book? Should a beginner really read and understand this proof? I don't think so. It will not be important when participating in, for example, code forces. It's important to practice the skill to prove complexity or think whether something is possible. But I would leave it for later. Maybe there should be a section, create a later chapter for proofs, move can do faster than n log n, proof there. The lower bound for the time complexity can be proved by considering sorting as a process where each comparison of two elements gives more information about the contents of the array. The height of the tree must be at least logarithm of that. Get a lower bound for this sum by choosing the last n divided by two elements and changing the value of each element to this. This yields an estimate. Yep. The height of the tree and the minimum possible number of steps in a sorting algorithm in the worst case is at least n log n. Fine. Here I would add is equal to. Can I copy this? Which is O of n log n. Counting sort. Actually, this shouldn't be O. There are special notations that mean exactly of this order. Actually, O of something means this order or smaller. So if you have constant time algorithm, you can say that it's O of n square factorial, even if it's just constant time, because O of means this or smaller. That's just for your information. The lower bound n log n does not apply to algorithms that do not compare array elements but use some other information. An example of such an algorithm is counting sort that sorts an array in O of n time, assuming that every element in the array is an integer between 0 and c. And c is O of n. Bookkeeping array. I haven't heard this term. Whose indices are elements of the original array. At least not in the like not about an array. The algorithm iterates through the original array and calculates how many times each element appears in the array. For example, the array corresponds to the following bookkeeping array. So is it a formal word? Algorithm bookkeeping array. You have to keep track of the presence of or the absence of value in an array. I wonder whether bookkeeping array is an official term, because I haven't heard about it. I would call that counter array, like an array with counters of occurrences, counting array. Here maybe a pseudocode would be nice, because it's very short. So add code to bookkeeping array, because it's just like what, 4 lines. For every element here, increase the count. Well, if we want to then use that to retrieve the array, then it's longer, but maybe. For example, the value at position 3 in the bookkeeping array is 2 because, okay, this is terrible explanation. 3 is at 2 because 3 appears 2 times. No, it's not because of that. It's because this prefix in total is 3. Incorrect explanation. Because the number oh, this is not the explanation how to retrieve it, it's the explanation why we have 2 here. Then it's fine. It just explains what happened, not what to do to retrieve the array. Anyway, I think this is the harder part that should be explained. This should be explained. Sorting in C++. It is almost never a good idea to use a homemade sorting algorithm in a contest because there are good implementations available in programming languages. This section will see how to use the C++ sort function. The following code sorts a vector in increasing order. Again, this should be non-decreasing, but I think for the sake of explanation, maybe add how is the thing in the bottom? It's a footer. Add a footer explanation once that in fact we sort non-decreasingly, because it's not an increasing order. Can you tell about C++ sort? Some insights. I think it's so it uses some heuristics. For n smaller than something like, I don't know, 15, it uses bubble sort because it's very fast. Then it uses something else, and I think it is very fast, especially if the initial array is already sorted or almost sorted. It uses some heuristics. So I think in Java, for example, there is team sort. You can read about it or watch video on YouTube by Gorev Sen, where that algorithm cheats a little bit. If it sees that the next few elements are increasing, then it assumes that maybe the next few elements will also increase. It will always be correct, it's just that it tries to be faster thanks to understanding how the array looks like. But generally, if you want, for example, to read about C++ sort, then just Google it and read about it. But it isn't important for us, for competitive programmers. After the sorting, the contents of the vector will be blah. The default sorting order is increasing, but a reverse order is possible as follows. Where here it's easy to miss the R, but yeah. An ordinary array can be sorted as follows. Sort A plus the following code sorts the string S. Sorting a string means that the characters of the string are sorted. For example, becomes okay. Comparison operators. Sort requires that a comparison operator is defined for the data type of the elements to be stored. Pairs are sorted primarily according to their first elements. However, if the first elements of two pairs are equal, they are sorted according to their second elements. Order of pairs is 1, 2, 1, 5, 2, 3. Okay. In a similar way, tuples are sorted primarily by the first element, etc. Okay. User-defined structs. The operator should return true if the element is smaller than the parameter and false otherwise. Okay, if x, px return that, else return that, that's fine. I also put const here, but I guess it's not necessary. Here author has used brackets instead of make tuple. Yep, that's true. And also for pushbacks. Well, like mplace book bit better, but this is easier to understand maybe. Hey Errichto, in which company you work? I don't work in a company. It is also possible to give an external comparison function to the sort function as a callback. Do you also do machine learning? No, I don't. I did in the past, but I don't like it that much. So we can write a function. Okay, binary search. General method for searching for an element in an array is to use a for loop that iterates through elements of the array. For example, the following code searches for an element x in an array. The time complexity of this approach is O of n because in the worst case it is necessary to check all elements of the array. The order of the elements is arbitrary. This is also the best possible approach because there is no additional information available where in the array we should search for the element x. If the array is sorted, the situation is different. Method 1. The search maintains an active region of the array which initially contains all array. Are you planning to do a stream on this year's hash code? Maybe after the finals. So then I will recap both the qualification round and the final round. At each step, the search checks the middle element of the active region. If the middle element is the target element, the search terminates. Again, don't use stuff A and B. Binary search. Again, don't use variable names a and b. I use low and high, and this I call middle or mid for short. In short, the algorithm halves the size of the region at each step, so the time complexity is log of n. Method 2. The search goes through the array from left to right. Okay, so that's I think harder approach. During the search, the variable b contains the current jump length. So this is an implementation where we start at position 0 in the array, and we consider jumping by a big power of 2, whatever doesn't exceed. Oh, it's not necessarily a power of 2. Okay, but then is it correct? We jump by n divided by 2. So for f3, I don't think this is correct. What happens if n equal to 3? Then b starts with value 1, and we can at most once add 1, and that's it. We can never reach the last element. So this is an important issue. I must remember to scroll. Method 2 is incorrect. For n equal 3, we will at most once jump by b equal 1. Instead, we should start with b equal ceiling of n divided by 2, I think. Or maybe we should assume n is a power of 2. Or maybe b must be a power of 2. So this is very important thing. Maybe even I will put that in bold, because it's simply incorrect right now. This will not work for n equal to 3. But it's close to that. I think here doing n plus 1 divided by 2 is fine. The other thing is that this method is just harder than the first method, and nobody uses it, I think. Remove method 2 completely, or mention it, or describe it later. For example, in LCA. The C++ standard library contains the following functions that are based on binary search and work in logarithmic time. Lower bound, upper bound, equal range. Wow, I didn't know about this equal range thing. So the first whose value is larger, at least. Okay. The functions assume that the array is sorted. If there is no such element, the pointer points to the element after the last array element. If there is no such element yet, it's important to understand that you don't here talk about x, about that value greater or at least x. By the way, if you have issues with YouTube, and there are issues with YouTube, then just go to Twitch TV/Errichto, because the stream refreshes every few seconds or so on YouTube. Maybe, by the way, YouTube stream issues or refresh. I wonder whether there are some news from the like recent hours. Settings, tools, anytime past 24 hours. YouTube down or app not working. No problems at YouTube. Trying to watch Blade Trip on shrooms. Watching live stream on YouTube keeps cutting out, then back in quickly. Annoying interruptions of conversation flow. Referring really badly. Yeah, so there are some issues with YouTube right now. Okay. The function, for example, the following code finds out whether an array contains an element with value x. AutoK is lower bound minus array. If somebody doesn't understand pointers, he will have no idea what happens here. We decrease, we subtract the array. C++ functions say that we can subtract pointers. So iterator minus begin is the index. Then the following codes, so here for vector this should be vector.begin. Then the following code counts the number of elements whose value is x. Yep, using equal range the code becomes shorter. Auto is not mentioned earlier. Auto. Yep. Explain auto. The Hitchhiker's Guide to the Programming Contest is also a good handbook, but needs some familiarity with math and programming. Let's check it out. The first thing is subset sum, so indeed it's not so easy. I think any good book should contain drawings, by the way. Of course it requires more effort. I'm not saying any of those authors did a bad job, because it's anyway a big amount of work. So this is, I guess, something for stronger competitive programmers who want to learn something new. String matching to the arrays, rectangles, graphs, the sample programs. How do sample programs look like? And for long codes, some color formatting would be nice. Check out. The hitchhikers and competitive programming free. By what? By whom? Where is the author? Oh, okay, doesn't matter. Not free. This is a good thing for me about streaming, what I'm doing now, that somebody can suggest something new. Finding the smallest solution. Suppose that we wish to find the smallest value k that is a valid solution for a problem. That's complicated. Now the value of k can be found using binary search. Okay. The search finds the largest value of x for which OK of x is false. Oh, he again uses some strange thing. If we know the range, okay, here we don't know the range, then we should go with jumps from 1 up, 1, 2, 4 and so on. The initial jump length z has to be large enough, for example some value for which we know beforehand OK of z is true. But if we know such value, then it's better to do a standard binary search. I don't like this one. The smallest solution, change to standard binary search if you know the right bound z, or use binary lifting is called, or do z times equal to till you find such. It's called binary lifting. I don't like this approach. The algorithm calls the function log of z times, so the total complexity depends on the function log. For example, if the function works in O of n time, the total complexity is n log z, finding the maximum value. Binary search can also be used to find the maximum value for a function that is first increasing and then decreasing. Such a function is called Bitonic or Bitonic. Finding the maximum value. Increasing, decreasing is called Bitonic or Bitonic. Link to the document that you are editing, please. So far I'm not publishing this. Maybe I will in the future. I will see. Okay. I think it's called ternary search. No, so the thing that we'll do here, it will be ternary search. Well, I think here we don't do ternary search because just looking at one place is enough. We don't ternary search, but the name of this kind of functions that first increase and then decrease are called Bitonic, and the ternary search is possible if and only if the function is Bitonic. The idea is to use binary search for finding the largest value of x for which this implies that blah blah blah. So as you see here, this is not ternary search because we don't look at 1/3 and 2/3. Instead, we just look at the middle and compare the value with the next value. Unlike the ordinary binary search, here it is not allowed that consecutive values of the function are equal. Actually, it's okay that values at the top are equal. So no thanks. Close. This function, even if it has a few, this function is possible to run ternary search on. It's okay that some values at the top are equal to each other, while now if I add these points here, a few equal points in a row, now it's impossible to run ternary search. It might be incorrect. So the required condition is that values increase, then they're equal for some time, then decrease. So here it's okay if max values, if there are several max values, several consecutive elements with the same max value. Data structures, chapter 4. It is important to choose an appropriate data structure for a problem. Here it will save a lot of time. This is ambiguous because he doesn't say whether it's about saving time of implementation or maybe this will be faster. Later in the book we will learn about more sophisticated data structures that are not available in the standard library. Dynamic arrays. Vector. The following code creates an empty vector and adds 3 elements to it. The function size returns the number of elements in the vector. Yeah, this should be casted to int. Otherwise, so the issue without that is that if you implement, let's see what happens here. Let's say that I want to iterate till the second last element. So my compiler warned me about this comparison. Let's see what happens now. Numbers 2 and 5 are printed. And what if I have an empty vector? Error. Attempt to subscript container with out of bounds index 0. How could this happen? What if I just print the index? Let's try the previous version. Zero and 1 was printed, and let's try a version with empty vector. Whoa, it's not intended. The thing is that this is unsigned int, and if you do 0 minus 1, you will get 2 to the 32 minus 1. Because there are no, this can't be a negative number because unsigned int doesn't have negative values. So this should be done. So remember to cast size to int. Now it's correct. Dynamic arrays. Cast size to int. A shorter way to iterate through a vector is as follows. Okay, but why won't you just write for int x? It's shorter and easier to understand. For int x in v cout x. I understand that with auto then you can change something to long, but why do we use it here in a book that teaches? I'm getting into competitive programming. I solve problems on CodeChef and Codeforces, but I want to increase my knowledge, so which book would you recommend for beginners? The Hitchhiker's Guide or the Competitive Programmer's Handbook? I'm reading this right now, and as you can see from 10 minutes ago, I didn't know about that other book. That being said, that Hitchhiker's Guide is much more advanced. If you are a beginner, then for sure Competitive Programmer's Handbook. The function back returns the last element in the vector, and the function popback removes the last element. The following code creates a vector with 5 elements. By the way, you can even do this. Another way to create a vector is to give the number of elements and initial value for each element. Yep. The question is whether that competitive programming free is better than this free book. So I will check it out eventually and will report back to you. The internal implementation of a vector uses an ordinary array. If the size of the vector increases and the array becomes too small, a new array is allocated and all the elements are moved to the new array. However, this does not happen often and the average time complexity. A new array is allocated. I would add, say that a new allocated array has twice the size. Just mention. The string structure is also a dynamic array that can be used almost like a vector. Strings can be combined using the plus symbol. The function blah blah returns the substring that begins at position k and has length x. And the function find finds the position of the first occurrence of a substring t. Okay. 0, 1, 2, 3 makes sense. Set structures. Data structure that contains a collection of elements. I think for beginners using just set is fine. You have to understand unordered set well to use it, and there can be some issues, plus it's not that much faster. By the way, if you want a fast implementation of a map of an ordered map in C++, in the description below you can see a link to my GitHub repository, and there in templates I have the fast hash table with also custom hash operator that I created, I think, in the previous or the second previous boring stream. So this should be much faster than the C++ hash table. Okay. The following code creates a set that contains integers. It shows some of the operations. The function insert adds an element to the set. The function count returns the number of occurrences of an element in the set. Count 3, count 4, yep, erase 3, erase A set can be used mostly like a vector, but it is not possible to access the elements using, so it's for sure not like a vector. What are similarities with a vector? You don't push back. I would remove that. Remove. I just don't agree with this. The following code creates a set. Hello Errichto, good morning. Hello Rohit. But it's not possible to access the elements using the blah blah. The following code creates a set, prints the number of elements in it, and then iterates through all the elements. Again, this should be int and can be int. Maybe what is useful here is to understand that this is sorted. So set of int s of 5268 will still print 2568. Give an example with this. All their elements are distinct. The function count always returns either 0 or 1. The function insert never adds an element to the set if it is already there. The following code illustrates this. Okay, now for multiset, what is the complexity of count? C++ multiset count. I think it's linear. Complexity logarithmic in size and linear in the number of matches. So be careful not to use count in map, assuming that in like multiset or multimap, because it can be linear. Warn that multiset count is linear. The function erase removes all instances of an element. Often only one instance should be removed, which can be done as follows. Map structures. Map is a generalized array that consists of key value pairs, while the keys in an ordinary array are always consecutive integers, where n is the size of the array. The keys in the map can be of any data type, and they do not have to be consecutive values. The structure map is based on a balanced binary tree and accessing elements. Yeah, so map is just, I think, a set of pairs, and that's it. While the structure unordered map, which is, I think, this is not just an ordered set of pairs, because only the first value is a key, but it's similar. Map structures. Say that map is a set of pairs. Am I sure about this? I'm not 100% sure. The keys are strings and the values are integers. If the value of a key is requested but the map does not contain it, the key is automatically added to the map with a default value. For example, in the following code, the key with value 0 is added to the map. The function count checks if a key exists in a map. The following code prints all the keys. Again, this can be pair of string int, just auto is if you don't want to write that down. In a book, I think we should. Iterators and ranges. Okay, so it's maybe a bit bad here. Mentioned that I said something about subtraction. Where was it? something about subtraction. Say that we can subtract pointers, or say it will be later in chapter about pointers. Does mCount also add it to map? I don't think so, but we can check. Map of int mCount 5 and cout mSize. No, it doesn't. 0 is printed, what means the size of map is still 0. This did not add. Well, if I do here print m of 5, 0 will be printed, but also that key 5 will be added. Here we see size 1 here. The asymmetry in the iterators. The often used iterators begin and end define a range that contains all elements in the data structure. The iterator begin points to the first element, end points to the position after the last element. The situation looks as follows. Note the asymmetry in the iterators. Begin points to an element in the structure, while end points outside the data structure. Thus, the range defined by the iterators is half open. Do you think you'd cover suffix trees construction in the future, like the economist algorithm? It would be super useful. No, I'm not going to do that because I'm not very good in string algorithms. Somebody else should do it. Working with ranges. Iterators are used in C++ library functions that are given a range of elements in the data structure. For example, the following code sorts a vector using the function sort, then reverses the order of the elements using the function reverse, and finally shuffles the order of elements using the function random shuffle. These functions can also be used with an ordinary array. In this case, the functions are given pointers to the array instead of iterators. Set iterators. Okay, the element to which an iterator points can be accessed using the star symbol. For example, the following code prints the first element in the set. Iterators can be moved using the ++ and - operators. The following code prints the largest element in the set. Just move this to the next line, I would say. The function find of x returns an iterator that points to an element whose value is x. However, if the set does not contain x, the iterator will be end. The function lower bound in both functions, if such an element does not exist, the return value is end. These functions are not supported by the unordered set structure, which does not maintain the order of the elements. I would add some code here maybe. So we lower bound. If this is begin, then print. Else, if this is the end, print the last element. Otherwise, just again A and B. This is first not smaller, and this is first smaller. Set iterators. Comments or meaningful variable names in nearest to x example. The code assumes that the set is not empty and goes through all possible causes using an iterator it. First, the iterator points to the smallest element whose value is at least x. If it equals begin, the corresponding element is nearest to x. If it is equals end, the largest element in the set is nearest to x. If none of the previous cases hold, the element nearest to x is either the element that corresponds to it or the previous element. Other structures. Hello, Sazat. How would you use augmented BSTs? For example, given rank select operations. I don't understand your question already. Are you asking how to use BST in general, or what? Or are you asking, is it possible to augment the set in C++? A bitset is an array whose each value is either 0 or 1. The benefit of using bitset is that they require less memory than ordinary arrays, because each element in a bitset only uses 1 bit of memory. For example, if n bits, are stored in an int array. Okay. In addition, the values of a bitset can be efficiently manipulated using bit operators, which makes it possible to optimize algorithms using bitsets. The following code shows examples of using bit operations. Here, only later we talk about bit operators. So I would at least add a sentence. If you don't know this, it will be explained later. For example, if you want to find fifth element in the set, what would you do? There is something like augmented set. You can Google code forces ordered set, and if you will, the first link I think will describe how to use such a set. That it has a function. It has functions find by order and order of key. What means give me the smallest element and find the position of this element. So this is what you need. So just Google code forces ordered set. Yeah. And here we had, so somebody asked how much time was needed for some program to run. In C++ it was 2 minutes, and in Python it was 4 hours. Use PyPy. Maybe PyPy would help. And yeah, C++ is fast. PyPy is quite fast version of Python. Bitset also helps to perform complicated binary logic on set of elements with ease, like select query from where blah blah. This condition can be mapped to bitset. Well, yes, if we know which elements satisfy one condition and which elements satisfy the other condition, we can simply use AND to take the intersection of the two sets. Maybe this should be explained later when bit operations are mentioned and explained. Interesting. I didn't know that we can cast string to bitset. That's fine. A deque. Dynamic array whose size can be efficiently changed at both ends of the array. The internal implementation of a deque is more complex than that of a vector. For this reason, a deque is slower than a vector. Still, both adding and removing elements take off 1 time on average at both ends. Yeah, deque is very slow. Don't use it. Just use vector and create an extra int variable for the start. And when you want to remove the first element, then move the iterator to the right. And when you want to add some more elements at the beginning, then just when creating a new vector, you must start it from the middle of this vector, so you could move to both sides. Just deque is slow. Also, I think a deque can be simulated using 2 stacks. I'm not sure about it. Hello, Irakli. Hello. Stack. A stack is a data structure that provides all of one-time operations, adding an element to the top and removing an element from the top. Q. Yep, so stack is where you make a stack of objects. You can imagine it as some like blocks, one on the top of the other, and you just can take the top as the highest block. And a queue is how people work in shops or whatever. In a queue, the earlier you go there, the earlier you go out. A priority queue. Supported operations are insertion, depending on the type of queue, retrieval and removal of either the minimum or maximum element. Well, an ordered set efficiently supports all the operations of a priority queue. The benefit of using a priority queue is that it has smaller constant factors. A priority queue is usually implemented using a heap structure that is much simpler than a balanced binary tree used in an ordered set. Yeah, often you want to use the simplest possible thing for your use case, because otherwise the running time will be worse because it can do some extra stuff. So what happens on the back end is harder and more complicated. By default, the elements in the C++ priority queue are sorted in decreasing order, and it is possible to find and remove the largest element in the queue, so the first one. The following code illustrates this. If we want to create a priority queue that supports finding and removing the smallest element, we can do it as follows. Yep. And here we have policy-based data structures. So here we have an ordered set that I think Reddy asked about. The G++ compiler also supports some data structures that are not part of the C++ standard library. Such structures are called policy-based data structures. So this is index. This is just a name. The specialty of this set is that we have access to the indices that the elements would have in a sorted array. Find by order, yep, this is what I mentioned. Both the functions work in logarithmic time, but this is slower. Comparison to sorting. It is often possible to solve a problem using either data structure or sorting. Sometimes there are remarkable differences in the actual efficiency of these approaches, which may be hidden in their time complexities. I would say they are hidden most of the time in their constant factors. Let's consider a problem where we are given two lists A and B that both contain n elements. Our task is to calculate the number of elements that belong to both of the lists. For example, the answer is 3. I came across this few years ago, really good for ordered stats across these policy-based data structures. Yep, they are. Straightforward solution to the problem is to go through all pairs of elements in n squared time, but next we'll focus on more efficient algorithms. 1. Construct a set of elements that appear in A, and after this we iterate through elements of B and check for each element if it belongs to A as well. We can do that. Algorithm 2. Use an ordered set. Algorithm 3. Instead of data structures, we can use sorting. First we sort both lists. After this we iterate through both the lists at the same time and find the common elements. The time complexity of sorting is n log n, and the rest of the algorithm works in O of n time. The efficiency comparison. The following table shows how efficient the above algorithms are when n varies and the elements of the list are random integers between 1 and 1 billion. So algorithm 1 is what? A set. So we have set working quite slow, then unordered set being faster. I would say that usually it's not that much faster. And algorithm 3 that uses sort and is n log n, while this one is log. Sorting is faster, because sorting is very fast, while sets are slow. In this problem, this trace has an important effect of the running time. However, the most efficient algorithm is 3, which uses sorting. It only uses half the time compared to algorithm 2, even less than that. Interestingly, the time complexity of both 1 and 3 is n log n, but despite this, algorithm 3 is 10 times faster. This can be explained by the fact that sorting is a simple procedure and it is done only once at the beginning of algorithm 3. I would also guess that sorting is faster, much faster than using unordered sets. Maybe not faster than using smart hash sets, for example, ones that you will find in my GitHub repository. But yeah, sorting is very fast. And the rest of the algorithm works in linear time. On the other hand, algorithm 1 maintains a complex balanced binary tree during the whole algorithm. But is it because of cache hits? It's because sorting is easier than some trees. Trees will do more operations. So explaining that with cache isn't even necessary here. Just a tree has a lot of stuff inside. And that was chapter 4. So I like the book so far, by the way. I don't agree with some single things, but generally it's okay. For example, I think that indeed I like the example of 2 arrays and counting elements that are common. I think this is very important for people to understand. Maybe I should do simple videos about stuff like that. So I think it's a good idea for a video to take example of this problem and to say we can do that, that and that, but here you have n log n working faster because sort is very fast. Can you show the problem once? So the problem is for 2 lists, count the number of common elements. So for these 2 arrays, there are 3 common elements because those are 5, 2, and 9. They belong to both. And the 3 solutions are putting one list to a set, and then for the other to check whether each element belongs to a set. Then the same but unordered set, which is O of n instead of n log n. But still, the fastest thing is sorting. So sort both and just use 2 pointers. So this is not a good explanation of how to do it. After this, we iterate through both the lists at the same time and find the common elements. So this is not well explained. So maybe I will add that issue. Comparison to sorting. Explain algo 3 in more detail. Do you think the unordered set loses time because of hashing? It's like you ask me if this algorithm loses time because of how it works. The unordered set is based on hashing. How can I answer that? The slow thing there is the fact that it must use some buckets inside, and this has a big constant factor. So policy-based hash sets are faster. There can be a single number occurring multiple times and it hashes repeatedly. Oh, you mean that there are hash collisions? No, it's not because of that. So in a random sequence there won't be that many collisions, not so many that it will cause program to be slower. Just the way it's implemented, it's slow. You can read about it more by code forces policy based hash set. You can Google that and read about. Here you will find information why hash sets are so slow. I can paste a link. Now the next chapter is about complete search, what means iterating over subsets or over all the permutations. We have 30 chapters, so each is roughly 10 pages. Yep, and we did 3 of them. Data structures. No, sorry, we did 4 of them. Complete search is a general method that can be used to solve almost any algorithm problem. The idea is to generate all possible solutions to the problem using brute force and then select the best solution or count the number of solutions depending on the problem. Generating subsets. We first consider the problem of generating all subsets of a set of n elements, for example the subsets of blah blah. Method 1. An elegant way to go through all subsets of a set is to use recursion. The following function search generates the subsets of the set. The function maintains a vector subset that will contain the elements of the set. The function maintains a vector subset. I think it's better for the sake of explanation to here put this vector subset so far as an argument, so you wouldn't have to pop back here. You just push back this new thing and run search of k plus 1. When the function search is called with parameter k, it decides whether to include the element k in the subset or not, and in both cases then calls itself with parameter k plus 1. However, if k equals n, the function notices that all elements have been processed and the subset has been generated. The following tree illustrates the function calls when n is equal to 3. We can always choose either the left branch or the right branch. To this drawing I would add what we chose so far, maybe. What is this chapter? Complete search. So, generating subsets. Method 1, add sets to write a set for every vertex. However, if k is n, the function notices that all elements have been processed and a subset has been generated. Maybe it would be useful here to add that vector of int method 1 declare vector of int subset above, and also method 1 write a set for every vertex on a drawing. Is this video refreshing for everyone, like every 20 seconds or so? Yes, there is something wrong with YouTube right now, and I advise you to switch to Twitch. Just go to Twitch TV /Errichto. People in the internet also complain that the live stream now on YouTube doesn't work. So go to Twitch. Method 2. Another way to generate subsets is based on the bit representation. On the bit representation, one moment, of integers. Each subset of a set can be represented as a sequence of n bits. The usual convention is that the last bit corresponds to element 0. The last bit corresponds to element 0. Okay, that's true. For example, the bit representation of 25 is blah blah, which corresponds to subset 0, 3, 4. 1, 2, 4, 8, 16, 24. Okay. The following code goes through the subsets of a set of n elements. The following code shows how we can find the elements of a subset that corresponds to a bit sequence. When processing each subset, the code builds a vector that contains the elements in the subset. Why won't you call it mask? Why B? This should be called M, at least, to say that this is a bit mask. Oh, B like bit mask, that makes sense. Still, just why not a name like bit mask or a mask? Method to, again, use mask instead of B or bit mask. Whatever. Generating permutations. Like subsets, permutations can be generated using recursion. You can either create a global, so maybe I will create a new subchapter, generating permutations. You can either create that global array, declare global array and a vector above. Global. You can either create this global array of Boolean values, or alternatively you can have a set for remaining elements and remove something from this set. This would work as well. For every element, if chosen, continue. I prefer the format if not chosen, then do this. Blah blah. Each function adds a new element to permutation. The array chosen indicates which elements are already included in the permutation. Another method for generating permutations is to begin with the permutation blah blah and to repeatedly use a function that constructs the next permutation in increasing order. In method 2, it's important to say method 2 say that it only works for a sorted initial array vector. The thing is that if you start with from permutation 0, 1 and so on up to n-1, then it's okay, but it doesn't work if you start with like 5, 2, 1 or 1, 5, 2, whatever is not sorted, because this goes only up to the permutation that is just sorted non-decreasingly and then stops. The array needs to be sorted though for using next permutation. Exactly. Sorted. Backtracking. Backtracking algorithm begins with an empty solution and extends the solution step by step. The search recursively goes through all different ways how a solution can be constructed. As an example, consider the problem of calculating the number of ways n queens can be placed on an n times n chessboard, so that no two queens attack each other. For example, when n is 4, there are two possible solutions. Okay, the problem can be solved using backtracking by placing queens so the board on the board, to the board, row by row. Solution has been found when all n queens have been placed. For example, when n is 4, some partial solutions generated by the backtracking algorithm are as follows. At the bottom level, the three first configurations are illegal because the queens attack each other. However, the fourth configuration is valid and it can be extended to a complete solution by placing two more queens to the board. There is only one way to place the two remaining queens. The algorithm can be implemented as follows. Search of y. So I would prefer a row instead of y, but that's fine. For if column diag. Maybe it would be better. Maybe it would be better to just iterate through cells that are in the same column or diagonal, because it would be easier to understand, but I think this is also fine. The search begins by calling search of 0, the size of the board. Again, I would add something global here to say that this is a vector of Boolean values or something. The code calculates, so this is what? Backtracking. Again, declare something global. The thing is that if somebody doesn't understand something inside, it would be useful for him to see that this is declared globally as an array of Boolean values. The size of the board is this, and the code calculates the number of solutions to count. The code assumes that the rows and columns on the board are numbered from 0 to n minus 1. Then calls itself with parameter y plus 1. The array column keeps track of columns that contain a queen, and the arrays diag 1 and 2 keep track of diagonals. It is not allowed to add another queen to a column or diagonal that already contains a queen. For example, the columns and diagonals of the 4x4 board are numbered as follows. Maybe I could ask the author for permission and I would just cover lessons from this book, video by video. I wonder if that makes sense. Because this is a good book. Where can I get the what? The emoticon? Column diag 2. Let q of n denote the number of ways to place n queens on an n times n chessboard. The above backtracking algorithm tells us that, for example, q of 8 is 92. When n increases, the search quickly becomes slow because the number of solutions increases exponentially. For example, calculating q of 16 is this using the above algorithm already takes about a minute on a modern computer. There is no known way to efficiently calculate larger values of q of n. The current record is q of 27, calculated in 2016. Okay. So here an important thing is hidden, that we increase the diagonal number. The diagonal of this type is x plus 1 and x plus y, and the other type is x minus 1 minus y. or the other way around. But this difference can go below 0, and this is why we add n-1, so it would be non-negative. Pruning the search. We can often optimize backtracking by pruning the search tree. The idea is to add intelligence to the algorithm so that it will notice as soon as possible if a partial solution cannot be extended to a complete solution. Such optimizations can have a tremendous effect on the efficiency of the search. Let us consider the problem of calculating the number of paths in an n times n grid from the upper left corner to the lower right corner. That goes through every square once. We focus on 7 times 7 case because its level of difficulty is appropriate for our needs. Basic algorithm. The first version of the algorithm does not contain any optimizations. We simply use backtracking to generate all possible paths from the upper left corner to the lower right corner and count the number of such paths. Well, the question is whether a reader understands what simply backtracking means here. Maybe a code should be given. Optimization 1. If any solution with first move one step down or right, there are always two paths that are symmetric about the diagonal of the grid after the first step. For example, the following paths are symmetric. Hence, we can decide that we always first move one step down, or just decide we move right, and finally multiply that number of solutions by 2. Optimization 2. If the path reaches the lower right square before it has visited all other squares of the grid, it is clear that it will not be possible to complete the solution. Oh, the lower right. So if we get to the end before ending. Using this observation, we can terminate the search immediately if we reach the lower right square too early. And now we get to 2 minutes instead of initial 8 minutes. If the path touches a wall and can turn either left or right, the grid splits into two parts that contain unvisited squares. For example, in the following situation, the path can turn either left or right. In this case, we cannot visit all squares anymore, so we can terminate the search. This optimization is very useful. And the previous is generalized. If the path cannot continue forward but can turn either left or right, the grid splits into two parts that both contain unvisited squares. Is that correct? Yes, it is. It is clear that we cannot visit all squares anymore, so we can terminate the search. After this optimization, the search is very efficient. Now it's 0.6 seconds. Now is a good moment to stop optimizing the algorithm and see what we have achieved. The running time of the original algorithm was 483 seconds, and now after the optimizations, the running time is only 0.6 seconds. Thus, the algorithm became nearly 1000 times faster. This is a usual phenomenon in backtracking because the search tree is usually large and even simple observations can effectively prune the search. Especially useful are optimizations that occur during the first steps of the algorithm, that is at the top of the search tree. Yeah, I would say that generally we should check if the remaining not visited cells are one connected component. If no, we cannot visit them all. Meet in the middle. Meet in the middle is the technique where the search space is divided into two parts of about equal size. As an example, consider a problem where we are given a list of n numbers and a number x. We want to find out if it is possible to choose some numbers from the list so that their sum is x. For example, given the list and x is 15, we can choose the numbers blah blah to get 15. So is there a subset in this set that has sum equal to x? This is called, by the way, knapsack. But if values can be huge, like 1 billion, then and is small, then meet in the middle will be more efficient, or just even the n-to-the-n algorithm. A simple algorithm to the problem is to go through all subsets of the elements and check if the sum of any of the subsets is x. The running time of such an algorithm is O of n to the n. I would say that depending on the implementation, it can be even 2 to the n times n. However, using the meet in the middle technique, we can achieve a more efficient 2 to the n divided by 2 algorithm. Okay. The idea is to divide the list into 2 lists, such that both lists contain about half of the numbers. The first search generates all subsets of A. Hi, please tell me where we can use dynamic programming in problems. The first search generates all subsets of A and stores their sums to a list as A. Correspondingly, the second search creates a list as B from B. After this, for example, suppose that the list is blah blah. First, we divide the list into this and that. After this, we create lists like that. In this case, the sum x15 is possible to form because as A contains the sum 6, as B contains that. We can implement the algorithm so that its time complexity is O of 2 to the n divided by 2. First, we generate sorted lists. After this, since the lists are sorted, we can check in that time. Well, this won't be, I think this will be n times that. Meet in the middle. Don't we have O of n times 2 to the n complexity? That's the end of chapter 5. And let's make a break from reading this book for now. We went through 5 chapters. So I can close that. Let's see what happens on Code Forces. So educational round will be in 3 hours. Grand Prix of America, so this is some ICPC contest, I guess. Yep. Microsoft Quantum contest happened, so I didn't have time to learn all of that, and I didn't participate. And this weekend on the 9th, what means Saturday, and there will be Croatian Open Competition Informatics Contest. By the way, there is a typo here. Open instead of open. I will maybe write to an author, you have a typo in the title. Open instead of open. If you are preparing for IOI, then this will be a very good contest for you. Yes, and times that should be the complexity, right? But how did the hashcode went for your team? There was this question already today, and you can read about it in Code Forces. Plus, you can see the leaderboard. We were 23rd, what I think is enough to qualify. Kaggle machine learning contests is my jam. Yeah, I'm not really good in machine learning. I competed in some basic contests in Kaggle machine learning, but didn't do very well. I would have to practice more. But almost every year I try to practice in their Christmas contest that is more about general algorithms and optimization. From where did you start learning quantum computing? A friend sent me a link to a book, or at least a name. I can, maybe I will look that up. I've read like first 50 pages. So I can quickly find it, just give me half a minute. But I would have to spend a lot of time to also understand the language, because we must implement in some Q hash or something. Nice, congratulations, thank you. But I wasn't very happy about it. Last year I won the qualification round. The book is called Quantum Computation and Quantum Information. Quantum Computation and Quantum Information. Computation. This is an incorrect word. You can Google that book. Do you suggest learning concepts topic-wise or in random order? However you like. For beginners, topic-wise is better, I think. But then to practice, random order is better, because you shouldn't just every time know what the problem will be about. If you when you learn flows and you go through problems on flows, it's easier because you know that you should use flows. Well, generally it's a big part of a problem is to see what this is about. What topics should I cover in discrete maths for competitive programming? Any book for it? I don't know any book for it. I can't tell you what to study there. By the way, the recent Codeforces round was a disaster, and you can see it by the number of downvotes. I think it's a record, minus 2,000. Maybe some of you didn't read what happened. The thing is that there was an official technical contest in the morning, and a few hours later there was supposed to be a Codeforces mirror round. They asked participants, of course, not to discuss problems during a contest or after, before the Codeforces round, so that we would have just a standard Codeforces round. The thing is that the contest in the morning happened in a few places. Like, it was on site in multiple cities, and in one city there was problem analysis session that was recorded and streamed on YouTube for other cities to watch, and it was just open. So there was for half a day there was a Russian editorial video problem analysis just available in YouTube, and at the beginning of Codeforces round somebody said about it in comments, and I think he was banned from Codeforces. So the first Codeforces staff assumed that this was hidden, but this guy found a link and gave it to everybody. Well, it was just public, and so I think people are pissed about this ban, and the initial announcement that said something like, let's see. Due to unethical and ugly behavior of some members of the community, this round will be unrated. Let's solve problems just for fun. Yeah, and the thing is that the organizers messed up, not the members of community. So that's funny. And this is why you see here 2,000 downvotes. As it was just a mistake. I understand that they didn't have a lot of time, and I answered questions regarding the problems, so they don't have that much time. And I understand that, but what happened is funny. Of course, Mike later apologized about the situation in a comment. Sorry guys, I did not understand the situation enough and sent the wrong broadcast. I apologize. I did not realize all the details about the streaming. I thought that it is more private. What makes sense. So Codeforces did almost nothing wrong. So just it happens. But you can scroll later through comments when Codeforces violates its own rules. So I think it's the fault of the on-site organizers who were responsible for streaming. Organizers of on-site round, organizers of the Codeforces mirrored, leaking the problems. Let's see who leaked the editorial. Some members of community, organizers of on-site round. As I advise to go through the comment section. It's a good laugh. Yep. By the way, the announcement doesn't deserve -1000, but this is how a voting system works. When somebody sees a hate train or like multiple downvotes, they usually also downvote, and because of that sometimes something very strange happens. Really, there is a useful comment and it would be downvoted to -100. So that's random, but I understand the community and being angry at organizers. So I wonder what was Khan's contribution before this post, because the votes in blogs written by you matter a lot for your contribution. So I wonder if he had like plus 150 before that. Not that it's important. The whole situation is fun. What else? Let's see what contests we have in the future. Exactly 24 hours from now, there will be SRM, Top Coder Round. Then on the weekend, on Friday, there is a mirror of some Petrozavets contest. Starting from Friday as well, there will be 9-day long or 10 days long coding game problem about writing AI bot. And on Saturday we have the quality contest, that is @Coder. @Coder never fails to provide very nice problems, so I will try to participate for sure. And also on Saturday, so just after @Coder, just after @Coder, there is 10 minutes break, and then there is that IOI contest, Croatian Olympiad contest. The website, by the way, is contestlist.by, clist.by. I'm a rookie. How should I do? What should I do to improve my competition? You should practice. You should solve more problems, or just read the book. For example, this competitive programmer's handbook that I'm reading now. Okay. So what, I can either read that. What else can I do? Let me maybe find, where's my streaming Google Doc is here. Let me find something to make the next video about. Oh, I noted down an example of a bad problem, by the way. This is so hard to understand. So this is so badly created, like written. Which practice site would you prefer for tricky problems if you have only 6 months for preparation? It depends on what you're preparing for. If you're preparing for National Olympiad, do problems from Olympiads. If you want to be good in Codeforces, do problems from Codeforces. Magical string consists of ones and twos and obeys the following rules. It's magical because concatenating the number of contiguous occurrences of characters 1 and 2 generates the string S itself. The first few elements of that is this. If you group the consecutive ones and twos, it will be blah blah blah. You can see that the occurrence sequence above is the S itself. Given an integer n as input, return the number of ones in the first n. So first of all, a single number is called a digit. They should say digits. The first n. So given an integer n as input, what they want to say, I think, is print the nth digit is in the magical string S. The other thing is that they should say if there is only just one such string S that satisfies this condition, this description. If I say a number is nice if it is equal to its number of digits or something like that, or the sum of digits, then multiple numbers will be okay. So they must clarify that. So that was an example of a bad problem. Is the stream refreshing frequently, or is it just my system? It's an issue with YouTube. Go to Twitch. Today YouTube doesn't work correctly. Problems. Easy standard DP. YouTube mention two pointers but solve with changing to the array of differences. Also refreshing occasional here, same for me here. Yeah, go to Twitch. YouTube doesn't work correctly today. I just hope that after the stream the video will be available as a whole, not sliced into parts of size 30 seconds. Video ideas. Okay. So recently I did a video of div1d problem, isolation. As was discussed in the comments, this is a nice video, but it will not reach a big audience. So I would prefer to often make videos on something easier. And either it should be something like div1b complexity, like difficulty, what would be fine, but still not accessible for people outside of competitive programming. This is why I did some videos on coding interview problems. That being said, most of those are boring. And it's also hard to decide how detailed an explanation should be. For example, in this find peak video, I could make this video last like 3 minutes and could explain everything. I decided to go in more detail, but this way it's more boring for those that understand it better. Stuff like that are hard to decide. For YouTube, nice medium problem. Okay, so I did that. Hard problem. Yeah, this was indeed a hard problem. Given an unsorted array, find the maximum difference between the two. Successive? Okay, successive. What I guess means the same as consecutive elements in its sorted form. And so the problem is easy to solve. You just sort. They say sort problems, sort numbers, and print the minimum of the difference of two consecutive ones. But here they ask us to do it in linear time and space, what is very hard. I managed to get a solution, but I didn't do it in a minute. This is a hard problem. Not possible for coding, like a programming contest like Codeforces, because it's too hard to distinguish O of n from n log n, especially if that n log n comes from sorting. I would prefer more details than less details, because I can change the playback speed if I think I know the approach. Makes sense. Okay, so maybe the next video will be about that. The related thing is not, I wanted to go to YouTube, is what series I should do. So I have some playlists. Like here I have competitive programming streams, coding interview problems. I think maybe it's written somewhere here. Boring stream. Okay, so I planned Codeforces algo problems, interesting ones, and those will be both hard and easier. So the series, well, series or playlists would be coding problems, coding algo problems, how to call that? Coding problem. So this would be around diff1b. Hard coding problem, diff1d, around that difficulty, and that isolation problem is an example of hard coding problem. But then also interview problem and hard coding interview problem. How do I call it? Coding interview question. This is interview question. Maybe coding problem. What should be better? Maybe coding question is better. Coding interview question. Okay, what is the number of searches? Coding problem 200,000 and coding question 100,000. Okay, I think problem is better. Solve hard problems from blah blah blah. In a moment I will get back to the chat. Yes, so I don't want to make 4 series. By the way, this would be this is trivial stuff. So the easy interview questions are really easy. Sometimes it's like, in a string find the first character that is unique, or the first character that appeared already on the left. It's just a simple implementation. While this is something more algorithmic. So how did I call that? Coding interview question. Yeah. And this there are also some coding interview questions that require thinking, like this maximum gap. So in brackets, I would put here easy coding interview question, but this is unnecessary. For some people, it will not be easy. Okay, what does chat say? Just divide and conquer. First 3 minutes of video should explain whole question and solution. Next 3 minutes explaining. I don't agree that this is a good approach. I think you should together with me in a video go towards a solution. The main difficulty, maybe I will say it differently. I don't think it's good just to hear a solution or to hear some more details about the solution. I think the difficulty in problems like code forces is to come up with a solution. I shouldn't explain details about a solution. I should show you an example thought process, the way to get to a solution. So far, all the time what I do is I talk, I present some ideas. For example, in the recent video, I said even something about a wrong approach that I had during a contest, because this is how my thought process looked like. And the solution is usually at the end. Please, on strings and suffix trees like this you can learn as well and teach us too with your superb explanation. I don't want to cover strings. I don't like those algorithms and I'm not good in them. I will stick to other algorithms. Tips and tricks for competitive programming. Solve hard problems from this. Arriving at a solution is better. Yeah, I also think so. So what is this related in any way to Competitive Programmer's Handbook? So this is the same website. Do you want to practice competitive programming? The blah blah problem set contains a collection of practice problems ranging from easy to difficult. Let's read introduction. This collection contains a set of practice competitive programming problems. To learn competitive programming, you may consider the following books. This handbook, guide to competitive programming. So this book is by the same guy, just it's more comprehensive version of the previous one. Describes a selection of more advanced topics, including square root algorithms and dynamic programming optimization. Advanced graph techniques, geometric algorithms, string techniques. Okay, so I understand that the free PDF is a good introduction, while this is a more complicated book. Maybe I will order that. I wonder whether it's on UK Amazon. Amazon.uk. Amazon UK. Oh, it's Co UK. Competitive programming. Okay. I recently won a competition organized by some events organized by G Research, trading company, and I think I won a gift card for British Amazon for £100, so I can order stuff like this. I should order something anyway, so maybe this is a good thing to order. Look inside. It's still 300 pages, so is the basic stuff removed? Generating subsets, permutations, time complexity. What is the difference? Let's compare that to this one. The difficulty seems same. What do you think about Google Office in Warsaw? It's very cool. They have a room for VR set, and the walls are covered with foam, like something soft, so you wouldn't bang your head on the wall. Yeah, it's a very nice office. That CoderDP stream was very helpful. It was balanced in explanation and speed. I'm glad you liked it. I also think it was a very fine stream. And I think it's the most watched video on my YouTube, by the way. So the order is different. What about the introduction? Time complexity, for example, is 8 pages here, and here it's 10 pages with also 2 queens problem. So it's different. It's like based on that what we have in dynamic programming. Coin problem, longest increasing. Longest increasing, paths. Okay, knapsack, paths in a grid, added distance, counting tills. I didn't want to hit that. How to get back? I can't. Okay, so it's similar. I can order that. Okay, back to checking out the problems. Statistics. Okay, so this is the leaderboard of people. The question is also whether they are okay with me solving everything on YouTube. Missing number. You're given all numbers between blah, blah, blah except one. Your task is to find the missing number. This is a cool problem if you have only constant space, by the way. There's a bit string that consists of n bits, then there are some changes that invert bits. Your task is to report after each change the length of the longest substring whose each bit is the same. Okay, I like those problems. They are very short and just not so hard. In array and integers, your task is to calculate the median of each window of k elements from left to right. Fine. Yeah, I can make streams solving those problems. The question is whether a stream would be better or a video. By the way, it takes me so much time to make a video. I already know how to edit stuff and to glue something together. When I first did that, it took me several hours because also I checked different software. For the recent video, it was just 15 minutes. That is fine. I also add subtitles, what takes, I don't know, 40 minutes to write down everything. But the longest part is making the video itself. because I record some part, but some I don't like some explanation, then I redo that, and I redo it so many times. I think I don't know if I should work on that, or maybe I shouldn't care so much. Stream would be better. Yes, you should make some short video about such specific problem. I'm not sure what is better. There's a channel called Free Blue One Brown where he has made his software open source in GitHub. His animations are pretty cool. Okay. Some README repositories. Animation engine for explanatory math videos. Animation engine for explanatory. I must eventually read about licenses, by the way. I know nothing about them and I need to, if I want to be in the world of education. I think there is some way to generate captions automatically than to write them manually. Yes, but automatic captions are very bad. Especially for technical streams. One thing is that my videos are technical, so there is stuff like O of n log n. The automatic captions will not understand that correctly. And the next thing is that my accent isn't perfect. I don't speak English perfectly, and because of that, it's harder for YouTube to understand it. Let's remove the voice. So here we have, oh, what did I do? I didn't want to do that. Get back. Just move down. I want the default placements. Or maybe this is the default placement. I didn't know that I can move subtitles. Anyway, here are my subtitles that I wrote down. Hello, my name is Errichto, and today I will show you how to solve problem D isolation. Well, there's also auto-generated ones that will do. Hello, my name is Arita, and today I will show you how to solve problem the isolation from count forces around instead of around 542, then around. We're given a sequence of n integers, that's fine, and we must find the number of ways to split this sequence. Yeah, most of the words are very good, like, but also there is no punctuation, there are no commas and stuff like that that would help you understand. And sometimes it will just be incorrect. 5k equal to 2. And the sequence itself, a segment containing all the numbers would be good because the unique numbers are 23. It should be 2 and 3. Maybe you can edit them to write from beginning. I don't know if that would be easier. It's easy for me to just write down something as the video goes. I just watch my video with speed times 0.5 and then I have enough time to write everything down. Editing, maybe it would be better, but I wouldn't save much time, that's for sure. Here we have some sums. Oh, I want to clear that array of predicate sums. It should be prefix sums and recompute those. So just add self is, yeah, and sometimes I use variable names or plus equal, stuff like that, where an equation would be better, like a code. Here add self was a function, and if we change to English, we have add self of a and b is a function that adds a plus equal b. Manim is an animation engine for explanatory math videos. It's used to create precise animations programmatically. With Python, some examples. Okay, we can draw a circle. That's very nice. That's indeed very nice. But that would take me a lot of time. It makes sense if I want to, I don't know, professionally create some materials, and a lot of people will then use that. Here I don't do something for such a big number of people. The thing is that if I now switch to doing something like that, then I will just create less materials because I will be much slower. But I understand that this tool is very nice. So I could, so if I want to do such an animation where letters change, that's awesome. On the other hand, I have my graphics tablet that I bought, and I can just draw stuff. In a moment, I will get back to the chat. And this is, I think, unnecessary. Like, it doesn't have to be that nice that it appears from left to right. Oh, it's beautiful. It doesn't matter, but yeah, it's nice, of course. I saw somewhere a way the fact that somebody wrote equations down in advance, and then by clicking at them, he showed them, what is a good thing. Coloring equations, yeah. Like, algorithms are, I guess, more about the drawings. I don't need, okay, so while I don't need the x's to appear so nicely, I like the way these functions are. So this is nice. This maybe would be useful in some algorithmic videos. The question is how much time it takes to create something like this. Whoa. Okay, so I will not need something like that, but I agree it's a very nice animation, and for explaining physics this would be awesome. Three-dimensional scenes. And the question is, can I use it at all? So what does MIT license mean? I would have to check. Sorry that I'm not reading the chat now. I just want to go through the videos. I'm close to the end of this site. Okay. I think you don't see examples on his GitHub. Yeah. The hardest problem on the hardest set. Yeah. Just remember that something like that has millions of views because that guy or institution has a big audience. So also it makes a lot of sense to spend tens of hours of time on everything. I'm not going to I'm not going to spend my own money and hire a team of people to do graphics and do stuff like that. And it's not that important. But if I was able to, yeah, this would be awesome. Though it isn't so important in algorithms. These videos exist thanks to Patreon. So it makes sense if they have a big support. This means something like $10,000 a month or more. I don't want to spend that much. And also I have a very small audience, so it doesn't have much sense for me to create something like Patreon. As long as I work alone, switching to this awesome format would mean I would create much fewer videos, because it would take me long days to create that. I think you would like his style of teaching. By the way, I did watch some of stuff like on YouTube, math popularization. I'm sure that I saw this kind of animation, the one with pies. This one. I did see something like that. So I sometimes get recommended on YouTube things like this. More about maths than physics. Well, there is something like number file. Yeah, I think he's very popular. To create very good videos also you have to really be very good in speaking English, while my English is possible to understand, but if somebody doesn't speak English perfectly himself, then he will have issues understanding me. So yeah, other people should do that, like popularizing of maths. Maybe you can edit them then to write from beginning. Maybe you can edit them then to write from beginning. I don't understand what you're suggesting here already. Watch the video from Rohit if you have time. So I did that. I think your accent is not a problem for most of the audience. It's easy to follow your speech during the stream. I agree, but it will be an issue for some. Yes, if somebody wants to explain a cool math thing in the YouTube, it's perfect if his English is perfect, right? Can you share your song playlist, some songs you listen to? I don't have song playlists. Whatever YouTube suggests me, I listen to. I like those that do not have important words in English, so that I don't have to focus on that. For example, a recent song that is in my mind often is like King of the Jungle, this one. The words are so basic. and part of them are in French, so I don't understand that, and it's nice to it doesn't distract me. Also Caravan Palace, the artist from Roots, Alice Merton. Before a contest or during coding, I often just, this is more on YouTube than on Google, just Google fast code, not fast coding, fast piano music. And I listen to, for example, this one in a loop. I hit loop and I listen to that for an hour. It helps me coding faster. But it's bad when you want to come up with a solution, because then it's unnecessary distraction. To save work on the subtitles, maybe you can upload a video in the different channel and then use this to download the auto-gen subtitles and then make a few edits. YouTube also generates automatic subtitles. They are just not perfect. I don't think subtitles are even necessary, to be honest. They are. For some people they are. Many people ask me about subtitles because their English wasn't good and they would prefer that. I also understand that because several years ago my English also was worse, and if I watched something in the internet, also just a movie, I would prefer to have subtitles for that, especially if the accent is unusual. For example, also, if I watched someone speaking British, like British accent, I would prefer to have subtitles, because their accent, the real British accent, is hard to understand. I can help with subtitles, +1 can see any need of subtitles. You don't see it, but some people do. Yeah, maybe I will outsource the subtitle stuff. But on the other hand, this is a small part of what I spent on a video. Right now it's something like 1 hour thinking about a problem, thinking how to explain it, maybe preparing a drawing, then 4 hours of recording, also with some improvements. Then I say, okay, I need a slightly different drawing. Then I would say 40 minutes for subtitles, 15 minutes for editing, and then like extra maybe 15 minutes for the description, changing the thumbnail, something like that. I think eventually I should ask some people to help with subtitles, but it isn't a big part of my time now. So that's fine. I just need to work on the meritoric part. So how to work more efficiently while recording and not to repeat so many times because something was wrong. Maybe shorter pieces would be nice, would be better. I can show you how files for the recent video look like. So here I have, starting from, so here at 11:40 I had some test of audio, but then I went to eat something, I went back 2:10, and then I recorded something, and there were many tries. I finished at like almost 5 p.m. So it took me 3 hours, which is fine. And if a piece of video was nice, then I just changed the name to here isolation 1 introduction. And here I have 1 minute where I just describe a problem, and at the end I say pause the video now if you want to think about the problem yourself. Then n-square solution is described, 4 minutes. Simple implementation, I talk about n-square solution. Square decomposition is mentioned. then the real solution and implementation. These two parts are longest. 5 minutes, like 4.5, 5.5. Yeah, maybe I should make smaller parts to be able to not repeat a few minutes if I mess something up. On the other hand, then it's harder to create one big train of thought. I don't want to make jumps every 10 seconds or every sentence. I remember there were some people in the chat asking for subtitles because they didn't have a good command over auditory English. No need of subtitles ++. Yeah. And I will say one extra thing. Even if 90% of people don't need subtitles, still that's fine, because I don't spend so much time creating subtitles, so it's good to also reach those extra 10%. And I think the ratio is different. I can actually go to statistics of some previous video where I had subtitles, and I can see what percentage of people used it. I think statistics won't be available for my last video still, because it takes some time for YouTube. For the isolation problem, right now it says that 2.3 people used subtitles, but I think that it's not accurate because it was published only yesterday. I will try to check the same for previous video, also with subtitles. Give me one moment. Hello from Vietnam. Hello. Just try it for a special problem or concept you want to talk about. Maybe it doesn't need to be in every video. I do it only for short videos, for those up to 20 minutes. I, of course, don't do it for streams. Or also, I did a stream for Google Hashcode. The stream was more than 1 hour. Then I didn't bother. Just for videos. For videos about a single problem, I do make subtitles. Okay, I have find pick element, 1000 views, 2 weeks ago or so. Analytics. I don't think animations are required for your channel. Please don't waste time. Instead, use it to make more content on topics on which most audience face some problems. Your accent is just fine, but by the way, yeah, I have I think about it in a similar way about those animations. I can actually show you all the statistics for this. So lead code, problem, find pick element. You can see that, so this is watch time, how much people watched it. And in the first day, it's of course much more than later, then fewer and fewer people watch it. On the bottom, you can see how many percent of people watched more than some percent. So the average watch time is 4 minutes, while the video is 16. And of course, a lot of people stop after the first minute because they don't find the video interesting. We have something like 35% after third minute, and till the end, it's almost the same, 20%. So usually, when people watch the first 5 minutes, then they often watch till the end. And the last minute is smaller because there is some extra talking there. What else we have here? Views, subscribers. So I see how many people subscribed while watching this video. What else we have here? We have traffic source, external. So how many people clicked from external to websites like Facebook. 72% of clicks from outside of YouTube come from Facebook, from my fan page. If people searched and clicked this, then usually they searched my nickname, Errichto. Suggested videos, this is very random. Okay, this is not so important. Interest viewers, what we have here. Not so important. And now build an audience. This is important. 70% of time comes from subscribed people. We have top countries here, what is a very strange statistics because it doesn't sum up to 100% at all. But generally, India and Bangladesh have more. I'm actually surprised by stats here. For streams, it's like India, Egypt, Bangladesh, Poland, United States, maybe in this order. And here, 21% used subtitles in English. And that is a lot. And if it's 20%, then I think it's fine for me to spend that half an hour, well, 40 minutes, as I said, on subtitles. There is one extra advantage of using subtitles. I will say that in a moment. Atcoder DP contest was the most viewed, right? You can use that to see the subtitles use stats. I didn't create subtitles for that stream because it was 5 hours. It would take me the whole day and it wouldn't be pleasant. So I will see the stats for this yesterday's video in a few days. But something like 20% using subtitles is reasonable. I can show you something more about the statistics. There was one very strange thing. This will be general channel statistics. So this show the total watch time, new subscribers, stuff like that. Let's hit lifetime. So since my channel was created, every peak is a video, often a stream. So my biggest watch time was when Atcoder DP stream was done. And then you can see here a smaller peak, this one for Algorithms Lecture 3, Exchange Arguments. But if I switch to new subscribers, this is such an anomaly. On the day of Exchange Arguments lecture, I got plus 200 subscribers, what is few times more than anything else later. At the beginning I had a lot of new ones because I was a new channel, so many people heard about me. This is such an anomaly. This peak makes everything later look very low. While for watch time wise it's more natural and easy to understand. Maybe it's because I was here in USA on Topcoder and I went back here. Many new people heard about me. I'm not sure. Yeah. And top videos are first sums and expected value lecture, then Atcoder DP contest. So Atcoder DP contest will eventually surpass. Will be the top one video of mine. Yeah. Generally 8% use subtitles, but for most streams there are no subtitles. So if they are available, then many people use them. And we have 0.1% of females watching. So these are statistics. What more we'll be doing today? What I will be doing? I might absolve some code forces problem. After all, I have now a working terminal and the Genie in Windows, so I can code. Technocup final. Actually, I tested this round of Technocup and I solved most of problems. already, so I can just copy paste them from Polygon. I will do that later. What I didn't do, because when I tested the statements were only in Russian, is power tree and secret letters. So I didn't, but I know how to do power tree. Maybe I will solve that today. And for this, I just didn't spend more than 1 minute thinking, so I'd have to either solve it from zero or read the editorial. Hi from Indonesia. Hello. Maybe I will upsolve this power tree problem, or just choose some old problems, old contest. What I have here, what is the recent diff1 contest that I did not solve? Code Forces global round 1. Maybe I will virtually compete in this one. I see a lot of easy problems, so that makes sense. Yeah, maybe I will do that now. How about global round 1, problem D? Read the unread messages. This is from like months ago. I always have 11 new messages. I will not click that because you would see my private messages, but there are like messages there are grouped into pages, and when I click that, I will see my like recent 10 messages or something, while those 11 are from months or years ago, and it would take me a long time to scroll to that to those. So I guess I will just never read those. When I click that, it will not disappear, because still some 11 not read messages are like hidden somewhere. Even just scrolling through pages, I would just not see which ones are not read. So I can spend some time, a lot of time, to just make this message disappear, but still I wouldn't find those messages. So it stays 11. Okay, so maybe I will solve this global round. The duration was 2 hours. Yep, 2 hours. Let's close unnecessary stuff. Okay, so that's it for today. Yeah, I will write to the book author and I will share my insight. Maybe he will want to make some changes. Virtual participation. Let's start at 14:00. Or should I make it a separate stream? Ask Mike to introduce feature which shows only unread messages. Maybe this is the best thing I should do. This is easiest for me. Okay, do I want to participate virtually here? Maybe it's better to make it a separate stream so that it would be just one video. Also these 2 hours. Yeah, I think I will make this into a separate video or stream, just like, for example, tomorrow. Separate stream would be good. Yeah, I think so too. So instead, what I can do instead. By the way, this looks so empty because here I have 6 of 6, 5 of 6, but then there is nothing much more. But most of those contests are division 2 or educational. Here I have division 1 that I skipped. Maybe I will try to get back to all the division 1 contests and solve problems from those. You can record video on your own and then upload it later, so that you need not look at the comments in between. Do you know? Yes, I can. It isn't even very hard for me. Are there any disadvantages? But do I want it to appear twice in my channel? So this stream plus that extra video? I think just a new stream is okay. I will announce that at that moment I will virtually compete in that global round 1. That's it. Do you know about compilation time calculation in CPP? Yes, I do. Using const expr or array and templates. Yes, it's pretty easy. So const expr and array are not like an important thing. Well, they are. I know it's possible, for example, to compute first primes during compilation time, not running time, but it's not useful in competitive programming. Yeah, so let's leave that global round for later. Here I have 1 out of 7. Oh, because this is some this is a Gaussian elimination problem, so I solved that. I think maybe during a stream even. I think I will go back to the research. What else I have open? Just maybe not the competitive programmer's book, because that would be boring for just 5 hours. So let me search for something else. Segment trees, Gaussian elimination. What else? Let's see Emacs. Not Emacs, the CP what? Emacs and English version. cpalgorithms.com. Let's see what they have. Binary exponentation. Make some videos on writing debugging templates, just like you made one for checking solutions if possible. No, I would have to understand C++ very well. The templates that I use, I don't understand even enough to explain that to someone. I only helped in writing those to my teammate Marek when we prepared for ICPC. I will not make a video on that. There's a good book called Modern C++ by Scott Meyers. Yeah, I think I've read it, or maybe a part of it. So I'm not an expert in C++, so I will stick to making algorithmic videos, because this is what I know. Binary exponentation is a trick which allows to calculate a to the n using log n multiplications. Most obviously, this applies to modular multiplication, to multiplication of matrices, and to other problems which we will discuss below. Algorithm. The idea of binary exponentation is that we split the work using binary representation of exponent. Let's write n in base 2. For example, this. Since the number n has exactly this many digits in base 2, we only need to perform logarithmically many multiplications. if we know the powers, so we only need to know a fast way to compute those. Luckily, this is very easy since an element is the sequence. In the sequence is just the square of the previous element. So to get the final answer for 3 to the 13, we only need to multiply 3 of them. Yep. The final complexity of this algorithm is log of n. We have to compute log of n powers of a, then have to do at most log of n multiplications to get the final answer for them, from them. Implementation. Recursive approach. Without recursion, yeah, I usually, by the way, use this like iterative approach. It's faster. But for example, here I write if b modulo 2 is 1, or just b modulo 2. This is harder to read for someone who doesn't understand bit operations. And here as well, like, this is not faster to write than b divided equal to. Applications. Compute x to the n modulo m. Solution. If m is prime number, we can speed up a bit this algorithm by calculating this. Oh, okay, they say that the exponent can be taken modulo m minus 1. That's true, but not really important. This is a good note, but not something important from the algorithm. Effective computation of Fibonacci numbers. Yeah, this is harder, and let's see how they explain that. For more details, see the Fibonacci number article. We will only go through an overview of the algorithm. Okay, let's read that later. To compute the next Fibonacci number, only the 2 previous ones are needed. We can build a 2 times 2 matrix that describes this transformation, the transition from fi and fi plus 1 to fi plus 1 to 2. For example, applying the transformation to the pair would change it into this, therefore we can erase. The explanation is good. On the other hand, I think such a topic is very hard for someone who doesn't know it. The golden ratio approximation for Fibonacci numbers is nice. Yes, but not useful in competitive programming. Do they say something about it? Here they give an exact formula. Yep. So on average, the ratio next Fibonacci number divided by the previous one is equal to the golden ratio, which is 1.618. The final complexity of this algorithm is of log. Blah, blah, blah. I was here. Where was I? Here. Yeah, for this algorithm, I don't know how easy to understand it is for someone who doesn't know matrices. How do we form such a recursive solution by ourselves, just like Fibonacci? Well, it isn't hard. So if I'm not sure if I understand the question, but to get the ratio at least, you do the following. You know that f of n is that. How do we form? Anyway, I will just show something. I don't know if I understand your question, but maybe I can remove everything. f of n is, what an ugly bracket. F of n is f of n minus 1 plus f of n minus 2. And if we say that every next element is greater times something, so we want to find some ratio for n close to infinity, then we'll have something like, let's say that this ratio is r. Then this is some value, and this is that, let's say that this value is x. Then this is r times x, because the ratio is r. The next, like, after n minus 2, the next number is greater times r, and this is r square times x. From that you get r square x is rx plus x. You can divide by x obviously because x is not 0, and you have r square is r plus 1, and from that you can compute delta or whatever the there is a technique to find the solution of this equation, and you will get that r is 1 plus minus square root of 5 divided by 2. So the ratio must be 1 minus square root of 5 divided by 2 or plus, and minus doesn't have sense because it's negative. So r here must be 1 plus square root of 5 divided by 2 if the ratio exists at all. And then there's a separate thing about proving that the ratio exists. What's the equivalent problems of div2de in topcoder SRM? Well, div2 hard or div1 easy in topcoder? Maybe an easier div1 medium as well. Okay, let's continue. I'm having difficulties in thinking such recursive relations. For example, Tower of Hanoi problems. I was able to think the solution, but I couldn't form relation. I don't know any magical hint regarding recursion in general. Did you solve problems from Project Euler? Are they comparable to competitive programming problems? Yes, but they are very much related to maths. And I'm not an expert in maths. But yes, there is similarity, and if you practice Project Euler, you will be better in competitive programming as well, especially in mathy problems. If you practice for ICPC, you need at least one guy in your team that will be good in maths. Applying a permutation k times. Also a survey. How many people in chat? Question for everybody in the chat. How well do you understand this paragraph? Do you know exactly what it does, or you don't at all, or did you not understand and now you do? So the fact that we build that 2 times 2 matrix that describes the transformation from one pair of numbers to the next pair of Fibonacci numbers. Check out the book called Concrete Maths. I think they talk about the recursion of Tower of Hanoi. They prove it by induction. I understand. Yeah, This is one of topics that I know that I wouldn't understand that in high school because, or maybe I would. I don't remember my math knowledge from high school, because I also do, but the paragraph is badly written. I think the 2 times 2 matrix part is confusing if you have not seen it before. I also think so. Maybe there should be an article about just matrix exponentation that says, okay, if you have 2 numbers a and b, you can multiply that by a matrix, and then matrix can be multiplied. just writing the matrix out would help. Yes, I think so too. Applying a permutation k times. You're given a sequence of length n, apply it to a given permutation k times. The question is whether everybody understands what applying a permutation means. I don't think so. Simply raise the permutation to kth power using binary exponentation, then apply it to the sequence. This will give you the time complexity n log k. That's true, but this task can be solved more efficiently in linear time by building the permutation graph and considering each cycle independently. You could then compute k modulo the cycle of the size of the cycle, and find the final position for each number. That's true. Matrix diagram they're explaining that would help. Fast application of a set of geometric operations to a set of points. Fast application. Okay, I understand. Given endpoints, apply M transformations. Each transformation can be a shift, a scaling, or a rotation around a given axis by a given angle. There is also a loop operation which applies a given list of transformation k times. You should apply all transformations faster than n times length, where length is the total number of transformations. I didn't understand the linear solution. Could you please explain again? What linear solution? Oh, here. Yeah, I can. Where is my pen? If the permutation says it's equivalent to giving a graph where maybe let's create a new drawing, and it's a graph with vertices that are numbers 1 through n. 2, 5, 6. So this is how you can represent the permutation. And if you know that the fact that we apply permutation k times means that from every number, like 1, you want to know what will happen if you move k times through along the edges. After one move, after applying a permutation once, from 1 you would get 3. Second time you would get 4, then 7, then 1 again. What you can do is find the cycle size, like write the cycle down, 1, 3, 4, 7, then take k, the number from the input, modulo size, and know that, for example, here size is 4, so this size is 4 here. If k is, for example, 10, then we'll move from this moment 10 times to the next number, so we will get at the end to the number on the right by k modulo size, which is 2. So from this number we will move here. From 3 we'll move to 7, from 4 to 1, from 7 to 3. So cycle of I is changed to the same cycle of A plus K modulo size. And this is a linear solution. You're welcome. Okay, now the next topic is much harder. It requires geometry, understanding what happens in linear algebra, I would say. The fact that we can combine geometric operations like rotations. Given endpoints, apply M transformations. Each transformation can be a shift, scaling, or rotation. Okay, let's look at how the different types of transformations change the coordinates. Shift operation adds a different constant to each of the coordinates. Scaling multiplies each of the coordinates. Rotation, the transformation is more complicated. We won't go in details here. Yeah, it's really complicated. But each of the new coordinates still can be represented as a linear combination of the old ones. That's true, but As you can see, each of the transformation can be represented as a linear operation on the coordinates. Thus, a transformation can be written as 4 times 4 matrix. Why not 2 times 2? Oh, we are in 4D. What is the number of dimensions? We have x, y, z, and 1 here. Yeah, I think we are in 3 dimensions. Why introduce a fake fourth coordinate, you ask? Without this, it would not be possible to implement the shift operation, as it requires us to add a constant to the coordinates. Without the fake coordinates, we would only be able to apply linear combination to the coordinates, not being able to add constant. That's true. You can't. Shifting a point by a vector is not a linear operation. We add an extra dimension to compute the extra identity. Yeah, so this one is the extra coordinate, but I think still we are in 3 dimensions. I think the problem is that those points are in 3 dimensions. Otherwise, I don't know why would we need z. Or maybe z is some angle, but I doubt it. Yeah, here we have coordinate z. Here are some examples of how transformations are represented in matrix form. This should be a lecture about matrices in geometry, not about binary exponentation. Here are some examples of how transformations are represented in matrix form. Scaling, rotation. Now, once every transformation is described as a matrix, the sequence of transformations can be described as a product of these matrices and a loop. Even the problem makes sense also without a loop and is equally hard. So really this is not about exponentation, just about multiplying these created matrices. Can be described as the matrix raised. Do you need to know algebraic geometry for this? Yes. The fact that rotation can be described by a matrix, by such a matrix, this is one thing, and the other, just the fact that we apply some matrices. For someone in high school, he will not understand that, I think. It's like a fake variable that helps to do matrix multiplication, I think, to scale down from 3D to 2D. Mapping this extra fake helps a lot. No, I understand that this is a fake variable, the 4th dimension, but these 3 are real. So I think the statement is that the endpoints are in 3 dimensions. Here they even give examples where we multiply every coordinate by something and they say something about coordinates z. Number of paths of length k in a graph. Yeah, this is a good stuff about exponentation of matrices. This is not. This should be moved to like algebraic geometry or something. Hey man, do you have any tips on calculating tight bound of nested loops with break statements in it? Is there any algorithmic way? I think it differs from case to case. I don't think there's a general tip about that. You just can notice that something will move to the right at most n times, so the total thing is O of n, even though there are 2 nested loops. Stuff like that. Maybe you should understand the technique of 2 pointers or caterpillar well to sometimes prove that amortized complexity because of break statements. Or maybe try to create a pessimistic test and think what will be the complexity on that test. Number of paths. Given a directed graph, find the number of paths of length k from any vertex to any other vertex. This problem is considered in more detail in a separate article. So for that they have a separate article and they don't for this stuff. That's stupid. But yes, this is a very cool thing. Maybe even I will create a lecture about it. Still, you have to understand matrices. I will think about that. The algorithm consists of raising the adjacency matrix M of the graph to the kth power, blah blah blah. Can you post the link to this website? Yeah, I always Google Emacs algorithms. The website is here. I didn't need this this explanation. I understood that from the article, by the way. But if somebody wants to read more about that fake variable, sure. Just like the explanation is, as I said, shifting is not a linear operation. In particular, any linear operation would have to transform point 0 to itself. This is one of conditions. If 0 is not transformed to itself but to some other point, then it's not a linear transformation. And this is why we create that extra variable, so that that important condition would be satisfied. What are some good medium level DP problems? I don't know, solve DP contest on AdCoder. How do you memorize all the algo like it's nothing? It's not true. How do people learn new language? They learn, they practice, and after years they speak that language. It's not that much different. People are capable of remembering tens of thousands of words. I guess this is the number of words in a language. So remembering 100 algorithms isn't harder. Okay, back to reading. Yeah, what is important is this note, I think, that not only we can multiply matrices, but also apply minimum instead of multiplication, what will give us the shortest path between some places. So we are given a graph, maybe directed with weights, and find the minimum weight of path with exactly k edges. This is done with matrix exponentation, but instead of multiplication we have minimum there. It's very similar to Floyd-Warshall, I would say. As shown in that article, this problem is also solved by exponentation of the adjacency matrix. The matrix would have the weight of the edge from I to j, or infinity, if there is no such edge. Yep. Variation, multiplying two numbers modulo m, and the product is too big to store in long log. Solution: we simply apply the binary construction algorithm described above, only performing addition instead of multiplication. Yeah, so we instead of computing a to the b, we compute a times b, what means doing addition b times. Note, you can solve this task in a different way by using floating point operations. First compute the expression, blah blah. See here for more detail. I like the style of these tutorials. They give links to some extra stuff, they put notes. This is a very good website. Okay, then we have this article and the one about Fibonacci numbers. Some cool tricks of matrix exponentation. I don't get, is it a question or not? Now let's cover the number of paths. And by the way, the stream will last for hour and a half more, so for up to 4 p.m. for me. I see a watch, by the way, on the screen. It's here. It's here in the corner. Just the camera covers it. Okay, now I need a like 5-minute break. I will, I don't know, grab a sandwich, and we'll be back in just a few minutes. Where is my be right back screen? Oh, it's not here. It was only in Linux. What I can do is I can do that. I can change this to be right back. Beautiful. Okay, that's very professional. Other than stream, what do you do? Are you working or nothing much? I organize contests. So I really made a lot of problems in my life, like invented a lot of problems. So also for code forces, and this is a job. You get money for inventing problems, or sometimes testing, depending on platform. Camera is still on. I understand. Yep. I didn't want to hide the camera or screen. That would be a nice answer for other than stream. What do you do? Are you working or? Yeah, I play on PlayStation. I played Uncharted 1 to 3 several years ago, and now there are new parts. I want to play them, but first I'm replaying the. Now I'm at Uncharted 3, but I don't have that much free time to play. FIFA, actually, I own FIFA on PlayStation, but I don't play so much. So for the last, I don't know when was the last time, half a year ago or so. Recently, how is it called? To finish a game. I don't remember a word. So I played Unravel 1 and 2. Maybe I can remove be right back. Okay. I played Unravel with my girlfriend. The second part is a cooperation game, and it's a pity there is only so few like multiplayer games for PlayStation where you can play with your friend who sits next to you. So that is a cool game. Unravel. Programmers are also good gamers. I also think so. I don't know the part that you can actually earn money other than winning the competition. Yeah, of course it's a job. Somebody organizes those contests. And big companies want to organize those. For example, Google Code Jam. It's a competition where the goal is for Google to hire and to bring more smart people to their company and to hire them. And they pay money for those problems. Actually, Code Jam is organized only by Google, so all the authors are from Google. But Codeforces rounds, or Top Coder, or whatever, authors are not. They don't work full-time for Codeforces, but still they are paid for their job. Besides algorithms, are there any other topics in computer science that interest you? I don't think so. There are some cool stuff. Machine learning is cool, for example, and parallel computing is nice. At least the one that is on distributed code gen. But yeah, I mainly do algorithms. Okay, I want to eat, so I will open the website. I will turn my microphone off, so it wouldn't be like ASMR for you where I eat. And I will just read through this. That being said, I know a solution. I just want to see how well it is explained. There was a very hard, I think, bubble cup problem that in particular required that. I think it's spoiled, night 2, and so on. There's a series of problems in bubble cup. Where here you have to count the number of paths up to up to k moves for a knight on the chessboard, and the constraints are here. The side is up to 24, but there are several versions of this problem. There's also traveling knight 1 and 3, I think. I think only 1 and 2. So the second one is already very hard. And this problem requires in particular this stuff. Are you not interested in getting PhD or master? No, I'm not. Can you explain and solve problems on convex hull optimization? Eventually I will. Not in this week or so. How much time you spend reading algorithms every day besides solving problems? I used to spend up to 15 hours a week. Now I don't do much apart from what you see like on streams or me competing in Codeforces rounds. I think I have seen this problem on LeetCode. They have a nice solution editorial. Okay, can you find this problem? I would want to see it and read the editorial. That would be nice. Okay, so I'm turning the microphone off for now. I'm back for a moment, and I think that this is done stupidly. I haven't finished eating, but this bothers me. Also, enjoy your meal. Goodbye. Goodbye. See you, Abraham. I will check this problem out in a moment. Something similar, not the exact problem. I want to practice problems on recursion, like forming recursive relations. I don't know any source. For stuff like that, for example here, you want to practice recursion, try to Google that. If you can find it, that also I will not be able to. That for later. And here, to move from counting paths of length k to paths of length up to k, I will show you what they do. Again, where is my pen? Here it is. They have some graph. What they described is that for every vertex they add one extra fake vertex. They make a loop from this vertex to itself, and a loop, an edge from the fake vertex to a real one. And the same for everything. And this is correct. Indeed, now every path starting in one of those, so if you start here, you can go for a long time with a loop, then start going here and doing something. And this way, every path you can change. Instead of counting paths at most k here, you can count paths that have length k plus 1 and start here and finish anywhere inside. Because the fact that here we will go through, I don't know, 3 times and then do something here, means that we have a shorter path here inside. So the correctness is okay. The issue is that we double the vertices, so instead of from n we get 2n, and the complexity of multiplying the matrix from n cubic becomes 8n cubic, which is very bad. Instead, what is enough to do, the solution that I know, is to create one fake vertex instead of n blue ones, put a loop to itself, and create an edge to each of those n vertices. Now, instead of 2n cubic, we have n plus 1 cubic, which is just the same as n cubic. So this was inefficient. So this was for blue color, and this is for red color instead. Now, if I see something like that, I would prefer to write to the author issues. What is the easiest way for me to report an issue? Here, I guess I will have to report it here on GitHub. So how to from this get Emacs algorithm? No, yeah, it doesn't matter much. Oh, there is a PDF version. They mentioned how to contribute, blah blah, contribute, I don't know. Okay. Okay, this is a nice book. 600 pages long, but this will be, I think it contains a lot of important stuff. Oh, a segment tree. They should make a book out of that. I need to fork source repository, but I need to only add an issue, I think. Or do I want to modify that? Actually, I would like it to be changed also in the Russian version. Let's see, can I get from this page to the Russian one? It will be emacs.ru. Maybe the others is different. Emacs. What now? Let's see how the addresses look like. Like that. Yay! Alright. What do they say here? Yeah, they also say that they add vertices fee. I think it's the same thing. Let's translate. Yandex Translate. This is the best online translator between Russian and English. It's very good. This can be done by slightly modifying the input graph. For example, if we are only interested in paths ending at certain vertex t, then we can add a loop tt of 0 weight to the graph. If we are still interested in answers for all pairs of vertices, oh, because they wanted to find answers for all the pairs. For example, if you are only interested in paths ending at certain vertex t, then we can add a loop tt of 0 weight to the graph. This is not correct. Because while going through a graph, you can meet that vertex t multiple times. And the other, okay, then the next thing is reasonable, assuming that we want to count for all the pairs. Then yes, we need to add, we need to double all the vertices. Okay, so I have an issue with this statement, and English statement just lacks this paragraph. What should I do to report an issue here? 5 years ago, yet. Okay, so let's try leaving a comment. I want to log in with my Facebook. Or maybe this is Gmail. Here we go. In the third last paragraph, adding a loop t is not enough, is incorrect, because we can use it would allow using it also in the middle of a path. Instead, a new vertex t prim should be created, just like in the harder version, similarly to the harder version for all pairs. Sorry for not writing in Russian. Okay, posted, and I hope that somebody will modify that, but I don't know how it works. I think after that, just English translation should be updated accordingly. Not sure about it. Hi, hello Judith. Maybe I will just read also this process of doing something. This is not stupid if I also contribute in some way to Emacs. I think this might be the best source of hard algorithms. I'm not sure about it, but that might be true. By the way, do we still have issues on YouTube? At the beginning of the stream, the video kept refreshing every few seconds or minutes. I wonder if it's still the issue. Okay, what happens here? Yeah, audio dead because I wanted to finish my sandwich. And now I'm done. So do they usually just translate? Or maybe write? I wonder whether there are some new algorithms in cpalgorithms.com that are not present in Emacs. No issues on YouTube right now. That's awesome. Okay, so number of paths. So this is correct, but necessary only for a version where we need to find that number of paths or the shortest path between any two vertices, instead of just in a graph or from one vertex. So this like generated book from all the articles is something huge. And it's, I think, very well written. I thought about writing a book myself or some materials, but I think there are so many of them, and it would be better just to gather them or improve them. Guess I am late. Yes, you are, but well, the stream still continues for 1 more hour. May you please share the link to the book? Here we go. So this is a book that I got by looking through issues in GitHub, marked issues, and somebody said, oh, this guy made a compilation of our oral articles into a PDF. Contributors. I wonder who is very active. So these are awesome people. We have Jacob Kogler from Austria, creating 12,000 lines. It's cool that so many people contributed in some way. New room? No, it's not a new room. Well, sometimes the camera is faced to my window that is there. You can see a part of it. So this happens usually when I'm not alone in my apartment. So I just right now everything would be visible. It would be hard for anyone to live with me. So if I'm not alone, then the camera faces the window. Can you do contest live stream like Petr? I'm worse than Petr, so it's not so important or nice. If I want to do well during a contest, I can't really explain a lot. Petr is better in that, so let better people do what they can do, and I instead will focus on this educational part. Contributing to Emacs would be great, maybe do it on a stream. Yeah, that's reasonable. What else? Fibonacci numbers, date probability. This is read. So educational contest starts in 1 hour. By the way, educational contests on Codeforces were a very good idea, and their quality is very nice. I like them. For beginners, I would even recommend those over standard Div2 rounds. because it knows authors try to invent some very special new problems that didn't appear earlier, while educational are good problems to learn from. Can you make a video on hashcode past problem? I've already did. I've already done. Just see on my YouTube channel hashcode recap. What do we have here about Fibonacci numbers? The addition rule. Applying the previous identity to the case and we get this. Even better, this can be transformed a little bit so that f to n uses only f of n and f of n minus 1, and this is how you can jump with just two values of f and do that binary explanation. From this we can prove by induction that for any positive integer k, this is multiple of that. The inverse is true. GCD. Okay, I didn't know about this. GCD of two Fibonacci numbers is equal to the Fibonacci number at GCD of indices. That's crazy. Fibonacci numbers are the worst possible inputs for Euclidean algorithm. Yep, that's true. Are you going to join educational round tonight? No. For me that would be just too easy, because like maybe two last problems are interesting, but other than that those are just easy, so I'm not going to participate. Just like any div2 round. Also, I said I recommend those for beginners. Well, for me, if anything, then I think div2 round would be more interesting. In educational round, often I see a problem that I already know, so that's boring. We can use the sequence to encode positive integers into binary code words. Any natural number can be uniquely represented as a sum of Fibonacci numbers, where this condition means no two consecutive Fibonacci numbers are taken. That's true, and this has a lot of properties. In particular, COI 2018, Warsaw, competition, tasks, Fibonacci representation. You can check out this problem that is even in English. It's a very hard problem. So somebody gave this problem, like there was an author who proposed this problem with constraints up to n 5000. I managed to raise the constraints to 100,000, and now it's a very hard problem. It's about counting the number of ways to represent a number as a sum of Fibonacci numbers, and nobody solved it during a contest. So do try that if you want. Are you going to join education around this? I've already read. The coding of an integer n can be done with a simple greedy algorithm. To decode a code word, first remove the final one. Yeah. Formulas for the n Fibonacci number, closed expression, matrix form. Well, here they explain what the matrix of transformation is. Fast doubling method. Yeah, but this turns out to be the same as matrix exponentation. Periodicity modulo P. Yeah. So there is some crazy fact that I think the period of Fibonacci numbers modulo any prime p is the size of that period is O of p, what is very strange. It should be p squared, but in fact it's O of p. There are some crazy problems about it. Why do you use Windows? Why shouldn't I? And Windows has nice OneNote for drawing and software for streaming. Okay, let's see this problem. A knight starts here, has 8 possible moves. Each time the knight is to move, it chooses one of 8 possible moves uniformly at random. Continues moving until it has made exactly k moves or has moved off the chessboard. Return the probability that the knight remains on the board after it had stopped moving. So this is an easy problem because k is small, so we don't need matrix exponentation. Solution, so it's just dp. Yep. So also they explain matrix exponentation. Let's see. Maybe I will read the whole thing. The recurrence expressed in approach 1 expressed states that transitions to a linear combination of other states. Anytime this happens, we can represent the entire transition as a matrix of those linear combinations. Then the nth power of this matrix represents the transition of n moves. Thus, we can reduce the problem to a problem of matrix exponentation. Okay, but so I agree with that, but still they don't teach matrix exponentation. Anytime this happens, we can represent the entire transition as a matrix of those linear combinations. First, there's a lot of symmetry on the board that we can exploit. Naively, there are n squared possible states. Because of symmetry through horizontal, vertical, and diagonal axes, we can assume that the knight is in the top left quadrant of the board, and that the column number is equal or larger. Yeah, that's true. This was, by the way, needed for the SPOI problem. This will reduce the number of states from n squared to approximately n squared divided by 8. And the matrix multiplication will be a lot faster. Now, if we know that every state becomes some linear combination of states, and we multiply that matrix. Yep. Time complexity is n to the 6 log k, which is bad, but now it's possible to solve even for k equal like 1 billion, while the previous solution was n squared times k, so it's bad for k, for huge k. Time complexity is that. Space complexity is this. The second solution uses Markov transition matrix. Its time complexity is much greater than that of dynamic programming. The reason is simple. That matrix is extremely sparse. Well, if it's dense, then also the complexity will be the same. But so this is the reason, the fact that it's sparse is why the first solution, this one, is quite fast. From every cell you can only go to 8 nearby cells, and the chess knight can only go to 8 cells. Okay. Do I have still something here? No, I don't. Yeah. We have 50 more minutes to go. And let's check some more Emacs. Oh, I have a new message. some more Emacs stuff. Binary experimentation, Euclidean algorithm, extended, this, that. Let's see how the sieve is explained. I got a long message in Code Forces, so I will read that later. Also, now I've read a message and I have again 11. They don't disappear. Sieve is an algorithm for finding all the prime numbers. That's a nice drawing. We mark all proper multiplies of 2. It would be nice to say what is proper multiply. I guess it means all the multipliers of 2 except for 2 itself. Okay, they explain that in the next sentence. We find the next number that hasn't been marked as composite. In this case it is 3, which means 3 is prime, and we mark all proper multiples of 3 as composite. The next unmarked number is 5, which is next prime number, and we mark all proper multiples of it. Next. Okay. In the following image you can see a visualization of the algorithm for computing all prime numbers in range 160. It can be seen that quite often we mark numbers as composite multiple times. Implementation. Instead of this, we can just put this condition here in the for loop. This would be shorter. Also, it's okay not to use this condition at all. Just here start from j equal to 2 times I. The speed will be the same. This is O log n. Now symptotic analysis. Let's see how to prove that. Oh, we have some calculus. So they prove that if they do that, here they could also have from j equal to 2 times I. Let's recall two known facts. The number of primes less than or equal to 2 is approximately that. True, it's n divided by logarithm of n. The kth prime number approximately equals k logarithm of k. That's true. Thus, we can write down the sum in the following way. Okay, so this sum, we are examining this sum and we want to prove that it will be log of n. Here we extracted the first prime number 2 from the sum because k is 1. Yeah. Okay, this is a special case, it doesn't matter. Now let's evaluate this sum using the integral of a same function over k from 2 to n divided by logarithm of n. Yes. If you want to find the sum of number from 1 to some n of some function, and this function is monotonic, it's increasing here or what, decreasing, then you can estimate that, or like bound that, by computing the sum over real values, and that sum would be integral. But of course, calculus is needed to understand that. Okay, I understand. That being said, it's not important. maybe every chapter should be marked as important or not. If somebody wants to learn the sieve of prime numbers, he should read up to this point and stop. He shouldn't read this part. Just say that it's n log n, because the sum of harmonic numbers is n log n, and that's it. Like, it's a log, sorry. Different optimizations. Sieving till root. Yeah, so here they do that up to n, but this doesn't do much. The number of operations will reduce noticeably. This is not true at all. We will solve only n operations, very fast ones. This is not a big difference between this code and the previous one. Sieving by odd numbers only. That's true. That's not true. It will reduce the number of operations performed by algorithm approximately in half. That's not true at all. The complexity is n log n, and by skipping even numbers, you only skip n divided by 2 operations. That's not half of all operations. Reducing consumed memory. Here they say that so vector of bulls or bitset has n divided by 8. Can I share a link? Yes, but also you can just follow me by you can also open that CP algorithms website and see what is there. In particular, this is sieve of Eratosthenes. Yeah, vector of bulls and bitsets are fast, meaning they take low memory, but then it's harder to ask about some particular value. Block sieving, yeah, this is something important, so I would just get rid of all of that part. Like, this is not important and this is important. I think in general Emacs is good for experienced people to learn new stuff, but it is a bad place for beginners that will not understand what should be, like, what they should read and what should they not. And here really up to this moment it's good, then here it's hard stuff, then it's unnecessary stuff, also not true that this reduces something in half. This is not important, and eventually this is very important, and there are problems that require that. Do you gain some hundreds of subscribers after a lot of this consistent streaming and uploading videos? I showed my statistics today. You can, it will be hard for you to scroll to that moment. I think on average now I gain, like, I don't know, 10, 20 of subscribers a day. And if I have some stream or a video, it will be more than that, maybe 50. Who cares about the number of subs? It is just useful and he's doing something. But the number of subs means that more people discover me and they gain something. And the fact that I do the useful thing is related to the number of people that will indeed learn from this. So I'm very happy about new people discovering my channel. It follows from the optimization sieving till root, and there is no need to keep the whole array. It's enough to keep just prime numbers until root of n. Let S be a constant which determines the size of a block. Okay, this is not what I had in mind. So they just save memory. The running time of block sieving is the same as for regular sieve, but the needed memory will be shortened to square root of n plus s. That's true. On the other hand, there will be a division for each pair of block and prime number, and that will be far worse for smaller block sizes. Hence, it is necessary to keep balance when selecting the constant s. Okay, so this is something nice, but not so important. I didn't see a case where this would be needed. And it would be needed if memory is slow and running time is big, allowed running time. Like time limit is 10 seconds, allowed memory is like 16 megabytes, then this is useful. What is important is something else that I would also call block sieving, where we want to find the number of primes in some interval from a to b, and that a and b are up to 2 to the 12, so huge numbers, but they're close to each other. B minus a is up to million. Then, and that's a nice problem that should be described here, I think. Linear time modification. The approach is described here. However, this algorithm also has its own weaknesses. Yeah, that algorithm is slow. Just standard sieve is fine. And here we have multiple problems on prime numbers. I will tell my friends, don't worry. Thank you, I would be happy about that. Who played the most important part in your team during hashcode? Well, I'm the most experienced in my team, but I coded only half of everything. The other half was Marek Sokolowski. Plus, I think Marcin gave us the biggest number of ideas, nice ideas. Also, he analyzed problem B and so, implemented something special there. And yeah, Julek helped him a lot with that, and with some visualization, general observations. So I think here we distributed the work nicely. Well, in the last year, I think I took the most important part in the team, while others were like to help visualize, help with a program, something like that. And we have a lot of problems. What is this, for example? Primes triangle. Your task is very easy. Given an integer from this, print its place in the primes triangle. Print -1 if n doesn't exist. So we must basically print the number of this prime number. And this is easier version. And there are multiple test cases. So you should once run the sieve and then know for every number where it is in this triangle. Actually, it should be, the problem is equivalent to, for a given prime number, say what is the number of smaller primes, smaller prime numbers. Just written in a stupid way. Here we have linear time complexity, but This is not something important. And I'm also afraid that when somebody learns a new stuff, he will think that this is important. Well, it is not. Mm. 0 to seconds, that's quite strict for this problem for n up to 10 to the 8. Yes, it is. You can check that. Submit solution. Okay, what I want to do. This is that limit, 10 to the 8. What memory can I use? 1 gigabyte, that's a lot. Oh, it was the other problem. Yeah, 1 gigabyte, so this array will be fine. Everything is prime initially. And then if is prime from I times I up to max, and what next? I need to say what is the ID in this array, so I need prefix sums, or just put them in a vector. For every number I want to know from up to 100,000, 100 million, I want to say which prime is there. No, for every number I want to say which prime it is. The first one is 1, and then I iterate from 2 up. Is prime of p, then answer of p is who, and plus plus who. Now for a prime p, I will know which it is on the list of primes. Now I need queries. If not is prime of p, print -1. Otherwise, print, for now let's just print that answer of p, and in a moment we must add the row and column number. I will be back in a moment. The prime triangle problem. Will you write educational code forces in 30 minutes? No, I already explained that. It would be boring for me. So those problems are usually quite standard. Those are for beginners rather than for pros. I think you are solving the 2 seconds problem. Why do you think so? So how do you think it should be solved faster than what I'm doing? Linear sieve is not faster than nlog version. Okay, so in the first row we have 1, 2, 3 and so on. So this is the number of things in every next row. I want to binary search the row, I think. Okay, maybe let's first run it for the tests that are already here. 3, 23, 4. I can measure the time. I compiled with O2 optimization flag. The running time is 1 second, which is quite big. Well, let's see. Maybe indeed I can't get accepted this method. I don't know how fast the SPOI system is, but if it works in 0.9 for me, it will not be much faster in SPOI. So I don't think this will be a correct solution. Let's see. Let's binary search the row. Do mark for even only and maybe use the array as not prime. I have an array as not prime. I mean is prime. Oh, you mean, okay, I understand. Doesn't matter much. I can later try to modify that, but I highly doubt that such simple modifications will improve the running time significantly. Low is 1, high is what can be the number of rows? 25,000, let's say. While low smaller than high, row is low plus high. Low plus high divided by 2. The number of numbers up to this moment is row times row plus 1 divided by 2. This is the sum, like this sum 1 plus 2 plus and so on up to row. Now if x greater equal answer of p, then high is row, else low is row plus 1. So row is now just low, and call is answer of p minus the number of numbers before this row, and all of that should be in here. We count from 1, so this will be 1 plus this. Do you think this is in this problem compile time computations work? The computational limit won't be so nice that we can do something significant there. Okay, maybe we don't count from 1. They don't even say what is the columns are numbered from 0 or from 1. Hey, 1000 queries or 10,000. 2, 3, 5, 7, 11, 13. Everything seems to work. Okay, let's submit that. Oh no, I didn't want to do that. Export display. It's not that easy to run something here. Oh no, my settings. No, my settings are fine. What I wanted to do is I wanted to copy this and submit it in SPOI. I need to sign in. Let's try first with that easier version. Submit solution. C++ 14. I want to copy that. Maybe it's impossible. Copy. Yep, it's impossible. Maybe it's possible from here. No, it isn't. So I can't copy my codes. How can I do it? Well, this is a file somewhere. Okay. I'm in C. I can copy ACPP here. Permission denied, maybe with sudo. Password. I don't have rights to copy. That's funny. Please press enter after selection. Okay. Now I messed something up and I don't see anything. So I want to mark and press enter. Yay! Thank you, guys. I did a cut. Yeah, thank you, Bluefuck. You helped me again. There are a lot of Binser implementation. Do you memorize this version? What's the implementation? Yeah, just I know this version. It's one based, I think. I finally know how to pronounce SPOI. Yeah, so SPOI is a website that that was created by someone from Poland, and in Poland you say SPOI, just like in English there would be a Y at the end. So for us it's SPOI, but I guess most people say SPOJ. Choose from file, from CMD, do a cut. Why don't you upload the file? I don't know if I can access that place. I'm not sure where I am right now. So here I'm in home Camille. I don't know where this kind of a virtual machine is. You can enable copy from terminal settings. I think I can't. I tried that today in the morning and there was no such option. Properties. So I think there is one option missing here. And I will investigate that later. You can use, okay, good idea. So this gives me just this path. It doesn't work like for the windows. It's not the same thing. Maybe I will see it here. No, I don't know where it is. Like later I will check. Doesn't matter. Doesn't matter now. Okay, I solved this. Total time 5.4. What is the total time over all tests? Now let's submit it for this one, but I guess indeed it will be time limit exceeded. And now we can experiment a little bit with so we have time. Now what happens if I here create a lot of numbers? I need a big prime number? Doesn't matter. Maybe let's go with okay, I do need factor. I'm looking for a prime number. This will be fine. Oh, I can't copy so easily. I can hit enter. This didn't work. Okay, it worked. Okay, it does work, it does. So I want to here create a file with 10, like what, 100,000 lines. I don't know, 100,000 numbers. Okay, so now this is a max test. And let's check the running time. Let's redirect that to output. Okay, so the answering queries is fast. Why did I get -1? Maybe first factor this number. Oh, I wanted to use this number, 5 to 1. And now enter doesn't work for me. No. 5 to 1, 7007. Find and replace. Yeah, that would be better. But this is also fast. 10, 20. I need 50,000 lines. Well, I should have written a generator. That would take me for sure less time. Yeah, it's fast. 1 second. So the speed is about this part. Now, first of all, is prime we set to true only for odd numbers plus for number 2, and here we start from 3 and also we move only by 2. By of 2 is true. The speed is roughly the same. Maybe I shouldn't create so big array. What will happen if I here will remove this? So this is the slow part. Let's check the same with vector of bulls. It's slightly faster. I can use this. Okay, so BlueFox said out multiplies only. I think this does the job. Have a second. Bitsets instead of vector of Boolean values. I don't think it will be faster. Let's see. Yeah, it's the same. Maybe even vector of bool is the same thing as bitset. Yes, vector of bool is bit packed. I just don't know whether the implementation is the same. You can mark with Ctrl M or mouse selection and enter to copy. Let's see. Ctrl M. Nope. Ctrl M didn't work. What else can I improve? Here I can iterate also like that. And first answer of 2 is 1 and plus plus 1. Let's make that a bit shorter. Maybe isn't necessary to go up to n, isn't square root of n enough? Well, here I go only to square root. I can make this array work only for odd numbers. So the size would be half of that. By the way, does it still work at all? Yes, it does. Don't mark even and check even. I don't now, because I iterate here, here, and here only over odd numbers. But what I can do is I can squeeze the memory. Everything will be faster this way. So isPrime will only work for odd numbers. I must remove this. here 1 up to max divided by 2 plus I. So just this would be filled with truths. Now from 1, this condition becomes hard. I will think about it. Here plus I. So now I want to only iterate over odd numbers. So is prime of 1 represents 3, is prime of 2 represents 5, and so on. Then if is prime of I, the square of 2 times x plus 1 is what, 4 times s square plus 4x plus 1. So this is a new thing. Okay, and I must divide it by 2. So I think here I have 2 times this plus 2 times I smaller than max divided by 2. I'm completely not sure about that. Well, just max now can be this divided by 2, so half of that, and now I don't need max divided by 2 anywhere. And this is just plus that. I really don't know if this is correct. Now this, and from 1 up to max plus p. If is prime, then answer of this is plus 1. For 5, it was incorrect. I messed something up. Let's see what the chat says. Maybe isn't necessary to go up to n, don't mark even and check even, I didn't see. In the inner for loop, can't we increment e plus equal 3 times I? I don't think so. J is 2 times I plus 1. Yes, I didn't know. Yeah, well, I didn't know either, I'm just trying to invent something. So something is wrong. Let's see if my calculations here are correct. If x represents a number 2x plus 1, then square of that is 4x squared plus 4x plus 1. Okay, so this will be represented by 2x squared plus 2x, and this is here. So I start from this value and I increase by I. But for it shouldn't, I shouldn't increase by I, by something else. Maybe 2i. For example, this represents 3. I want to jump every 6 like that. Yeah, you're right, Bluefog. Let's check that. Okay, something is wrong. Segmentation fault. But was it okay now? maybe an overflow. Okay, answer should have size 2 times next plus 5. Hi Errichto, what a way to write my nickname. Hello Lebob. So some numbers. Okay, I understand the issue here. Oh. Export display 0 Genie ACPP. Here answer should be bigger, and when I check is prime, I actually should check if if p is different than 2 or and p is even or not prime of p divided by 2. One, 2, 3, 4, 5, 7. Looks okay. Just for a 1 it's incorrect. If p is 1 or all of that. And let's see the running time now. Redirected to a file. We have 0.3. I will submit this. So still I must print here, mark and hit enter. What is stupid? Is this faster one? Yeah. Maybe. Time is exceeded. What about the simple version? What a time to be alive. You can go to cd home, then cd ... then to cd mount, then you can see your Windows CD drives. Yeah, I can, but I'm not allowed to copy to those. I'm not allowed to touch those files, even if I print my password. Okay, from running time 5.4, I got to 1.2 here, what is the sum over all tests, which is much better, but still not good enough. I can get rid of this, but I don't think that's significant. What happens if let's run that a few times? If I add return 0 here, yeah, it's much smaller than the previous part. You shouldn't touch system32 files, but create files in your Windows D folder so that you can copy them from your Windows. Yeah, I'm not trying to touch system32 files. I went to drive C and D. How did I get to CD? I have just a drive C. And can I write here? So permission denied allowed, ABC, CPP, permission denied. I tried that and it was also denied. But maybe if this wasn't drive C but something like E, this would be okay. Can I just create? No, I can't create a director here. Another time. So can I do anything more here in this problem? I can try doing this. Is prime of j plus 2 times I plus 1 is also false. Increase nags a little bit by square root. This should be const exp. And then move like that. So nags was okay, just the array must be slightly greater. Nags plus this. Let's check this. I think nothing changed. What if I do more of that? So I try to help my processor in like parallelizing this. It might help a little bit. Yeah, that didn't help much. C++, pragma, fast. There is a pragma to turn off fast. Yeah, it's like that. Maybe this will help a little bit. Nope. And finally, maybe this is an issue. So what about using return 0 here? Yeah, you can improve this in some way. What about gathering the primes? Maybe you can try to memory allocation in chunks of power of 2. It will not help that much. Oh, and educational round starts. Run WSL as administrator. Yeah, I thought about that, but I will just try that next time. I don't even know, by the way, how to run something as administrator in Windows, how to force that. But yeah, I want to try that later. You need to run your terminal with admin privilege. Yep, exactly. Time for code first round by. Bye-bye. Loop unrolling. Yes, this is called loop unrolling. Maybe you can try to memory allocation in chunks of power of 2. Yeah, so this I answered. I think it will not help. What I want to do is I want to get rid of this array, big array, because even allocating that much memory can take time. Instead, I will here just, instead of that, I will create a list for primes. I don't know how big it must be. Let's say that it will be that big. next divided by 5. Now IP is 0. Primes of IP++ is 2, and for every next number, if is prime, then primes of IP++ is p. So I don't need who. Now in primes I store the primes. What I now, instead of answer, I want to first binary search where this prime is in the array. I can even read queries and then do something, sort them and do something offline, but this isn't not important. Low is 0, high is IP -1. So I binary search where this prime is on the list of primes. If primes of I something, then low is I+1, else high is I. So I move to the right if this is too small. Now I binary search using not answer, but instead that which prime. Which prime, counting from, I think, 1. So let's try it like that. Nope. 2, 2, 3, 1. This is not correct. So maybe, what about without this -1? Maybe even I need extra -1. Why? What happened there? Something is wrong. Because here it's not p, it's 2 times p plus 1. So after all, this +1 was needed, and I think now we are okay. Yes. And the running time didn't improve. Can I make this even smaller? But it will not help much either. Or it will a little bit. Print IP. Oh, I don't know how to copy. This is enough. 5761458. And the last thing I can try is reading queries and then answering them offline. So let's try that. Queries, pairs, I think pairs, queries. With the number of queries queue. This is of that size. Read X, and queries of I is pair xi, sort them, and now answer them in this order. Consider. I will run consider with every next IP or every next P, just a prime, while next query smaller than Q and queries of next query first smaller than P, then plus next query. So we skip non-prime numbers. Then while next query smaller than Q and next query is exactly P, I put answer of queries of next query second as let's also count this IP. IP is, I need to increase IP by 1 somewhere. I will do that here, plus IP. I will need this there, but that's for later. For now, just say that it's IP. So I save answer here, size Q, filled with -1s. First I consider 2, then for every odd prime, if is prime, then consider that. Redeclared variable. Yeah, I don't need it here. Now, for every query, if answer is -1, then just put -1. Otherwise, we binary search the row, and which prime, what sounds like Twitch prime, by the way, which prime will be answer of I +1. There can be many things wrong here. Let's check. Oh, I need to first print everything, and then it will be run. Did I mess something up? I think so. I have an infinite loop because here I don't increase next query by 1. Let's do that. Okay. For 2 we have 1, 1, 2, 1, 2, 2. Yeah, it's correct. And the running speed again didn't improve. But now primes is not necessary. Let's try submitting that, but I don't know how to improve it further. What's the pre-computation time? Oh, again, I need to, in some complicated way, do that. You can see it here. It's like 1.2. This is including the memory allocation and then freeing it. So it's like less than 0.3. Is it a new version? Yes, it is. And let's again submit for the previous problem to see how much we improved. Time limit exceeded again. So I don't think I will solve this problem. Maybe some better SSE optimizations are needed. Yeah, so I improved from 1.2 to less than a second. So this is the sum of times on all tests, what suggests that I'm not far away from getting accepted, but I just don't know what I would improve now. Sadly. What's your tip for a guy who has zero knowledge about competitive programming? You can start by reading the Competitive Programmer's Handbook, or go, for example, to SPOI, sort problems by difficulty from the easiest ones, and just start there. Do as easy problems as possible, and then you will move on. Intrinsics needed on SPOI. Wow, what is intrinsics? Is it something like language related? Can you precompute all primes and store in an array? If you mean, can I submit code where primes will be pasted? No, because there is a limit for the size of code. Usually 100 kilobytes. Here it's 50,000 50 kilobytes. So 50,000 characters, which is too much. Like the number of primes is too much for me to store that in code. But here earlier I had them in an array. I had array primes and iterator IP that measured the number of them. I avoided vector because that would be slow. Yeah, so SSE intrinsics. So this is what I meant when I said SSE. And yeah, in some problems on SPOI, they are needed. Then just the problem isn't about algorithms. Less than 0.3. This is already much faster than the initial version, but I can't progress more. So what takes time now? Return 0. This is fast. This is fast, and maybe iterating over the numbers and considering the prime ones. Yes, so this piece of code takes 0.1. Can you use const exp? I can. I used it here, but it has nothing to do with the logic. Maybe this can be improved. This is not so fast. Maybe in the query you can prune for numbers that are not prime. You don't need to add in the queries because make per is also costly. But pessimistically, in a test, still this is not a heavy part. The issue is here where well, first this takes 0.2, then this takes 0.1. And here I iterate over primes from 1 to just the limit divided by 2 over odd primes, and I add them. Okay, I can avoid this if if I to the queries push in place back like infinity, maybe this will be faster. Nope, it's slower. At least for this test. Yeah, so Rohit, your idea makes sense, but still pessimistically there will be a test where all the numbers are prime. And then it will change nothing. I am going to read comments. Maybe somebody said something useful. Yeah, so nobody gave any useful hints in the comments. Here there are people that solve this problem. Also for the easier version, we can go to leaderboard and we can see, so I'm here with 0.96 while people here 0.74 already passes, what means that I'm very close. I need just an improvement by 20%. Perf stats, that yeah, I also doubt it. Maybe I would have to install some stuff, but I don't want to now. Yeah, later I might install perf. Is it possible to pre-compute the triangle? It's too big and it doesn't matter because this part is fast. The two slow parts are the sieve itself, that is here, and the like adding next primes. So getting rid of this part would be enough for me to solve a problem. Pre-computation is the part to optimize. So computing primes, I don't know how to optimize this further. I already did a very strange thing with these odd primes only. I think I will try to improve this part, and if I manage, indeed I will get that 20% improvement and I will pass the problem. Maybe. I can create the other array that says whether a query, no, if this is even, is present of x divided by 2 is true. Now apply this only here and is present of p. Let's try that. Maybe something smarter, because now I need more memory. Maybe it's not necessary. So just the running time of real part is like 0.25, and I think the overhead here is related to memory mostly, and I made things slower because of that. How to do it? Maybe I should mark here is prime as false and don't only do something for false values. Still, I can submit. See how it behaves in SPOI. This is harder version. Yes, I want to test on easier version. So I had previously 0.90 something, I think. Wrong answer. I messed something up. Why? Oh, here I have ++ IP. It should be here. Okay, what about now? Maybe I will just test it. Free one makes sense. Yep. We are already over time by half an hour, but I feel so close to solving this problem that I would be really happy squeezing that running time a little bit more. Wrong answer again. Did I submit the correct solution? IP. Yeah, IP is increased here. Okay, it should be increased here as well. What is your regular stream time? So far, apparently, I stream on Tuesdays. At least I had time this Tuesday and previous two. I want to find I want to fix my schedule, because I know that this would be convenient to viewers too. Okay, so I didn't improve by much. For now, I have Tuesdays, but that might change. I think in a month or so, I will really fix my schedule. Also, sometimes I'm trying to do weekend streams, but those are very irregular, also because of contests like on Codeforces or other platforms, where I have to choose such an hour, such a time, not to collide with anything. 0.91. It doesn't hurt to try. So what I changed is I here added plus IP. $72 gives accepted. And this is still time limit exceeded. If next query smaller than Q, here if is present, and queries of next query first smaller equal 2 times p plus 1. And I had that plus IP here. Whoa, that's faster. And that's correct. I think I lost a lot of time because I ran a function. What about define consider of p? I don't remember how to do something in multiple lines like that. Yep. Okay. Maybe. Let's first submit on the easier problem. I want to see 0.7 or smaller. This is not 0.7 or smaller, but there is a chance. Where is that harder problem? Here. Please pass. Ugh. Come on. But it's so much faster. Okay, maybe it's like Judge Heard you want. It's like Judge Heard what you wanted, yeah. Was such a nice experience of optimization. Yeah, hooray. Okay, but now where's my time limit exceed? Here it is. So just to make sure that I have time limit exceed, maybe I should just submit it again. And because there are very small fluctuations, so if I submit it 5 times, I think if at least once it will pass, right? Doesn't look like passing. And this is and here we have the easier version. Yep, it doesn't pass because this was the easier version. Yep, the one with 2 seconds. Faster IO, I can try, but it will give me just milliseconds. Yeah, it's n numbers, I do a lot more stuff. Get char unlocked. While true, char is this. If between that x is 10 times x plus char minus 0, otherwise break, return x. Let's see if it works. Yes, it does. What else? I don't remember how to print better. Like put char unlocked? Why can't we store the rows and calls during prime sieve creation? It doesn't give much. And the part about triangle is fast. So let's submit again on our this is easier problem, the one that is easy to get accepted. Maybe under 0.7, please. Okay, let's submit on the big problem. And let's make sure that this is a correct code. Yeah, with read. Time limit exceeded. Time A in out. Can I remove this is present completely? How will it change the time? This is slightly faster. Do you have Turkish family? I don't think so. Is it because of my name? I think Kamil appears in several countries. But I guess second name is more important. Yeah, so Kamil, but I think Kamil is from like Rome, ancient Rome. I'm not sure. So yeah, I'm not Turkish. Okay, let's submit this new version. And this process of submitting is very unpleasant. Arabic. I heard that it's from ancient Rome, like Camillus or something like that. Maybe it's Arabic. So the below will pass because it's the easier version of a problem. 0.7 still. I can change the printing part. I can get rid of this. What will I get if I return 0 here? Yeah, it does matter a little bit. So I can make this faster. So I need to take such row R that R times R plus 1 will be roughly equal to 2 times no, I know R, and R times this is 2 times X, and from this I want to this is 2 times which prime, and from this I need R square plus R minus 2 times which prime is 0, so R is how was it, minus 1 plus square root of 1 plus 8 times which prime, all of that divided by 2. Which prime is here? Let's try. Row is that. I can remove that. And now or I will do this plus 3, and while row times row plus 1 divided by 2 is greater or equal which prime, this will be faster, is 2 minus minus row. So far, is it correct? No, it's not. 0, 1, 1, 2. Maybe greater. Nope. What exactly I want from this? Well, this is smaller. Max of 0 and int width of that, and now plus plus. Looks fine. So maybe now it's a little bit faster because I removed binary search. I just used a formula. Can improve that just a tiny bit. Submit. Let me close a few pages. Put char unlocked. Yeah, I'm going to try that in a moment, but that shouldn't be significant. I make things slower actually. Maybe the formula is slower than binary search. Yeah. So C++ put char unlocked. somebody said that this function is fast. Let's see it. Right int, just let's say it will be right, and here I write, I can here put char minus, put char 1, put char new line, here write row, put char space, write call, put char new line. It works. Where's my time limit exceeded here? 69. That's faster. If we pre-compute rows and columns as well along with SIF, we'll remove the needed for binary search. I already got rid of binary search, whether the memory constraints would hold. Yeah, I don't want to add new memory, but on the other hand, if here I anyway iterate over numbers, I can actually put a row here. Let's say row is 1. Remaining is 0, or already is 0. Already is 1, and here if while that number 2 times p plus 1 is greater than already plus row plus plus, already plus equal plus plus row. So now here instead of IP I will save row. No, I need both. But maybe it's fine to here use pairs. IP and row, or just the whole thing, row and I don't want to compare that, I want to compare IP. I don't know what I'm doing. And here it will be IP minus already, something like that. So row and already must be here. What is wrong? Well, P is greater than already. A typo? Already. Here I see I guess some very fast input-output. Maybe I will try that. I wonder whether I will finish before the educational round on Codeforces finishes. What is wrong? Oh, didn't I change that? Print the first number in a pair, the second number, and a new line. Then continue. Now let's fix those ifs. Well, IP greater than already. Otherwise IP is smaller than already. Here's something like already minus IP minus already minus row. More or less. Let's check that. Actually, let me save to a file 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it's close. What about putting 0 here? Looks correct. Also, let's try here a bitset after all. Bitset of max plus 51 to 3 is prime. But I don't know how to fix that with truth. Maybe like that. Nope, that wasn't correct. Its prime is 1. No, doesn't work either. Okay, we got rid of this binary search. Now what? Let's try submitting. I didn't do that in like 5 minutes. And I think if I don't finish in like 10 minutes, I will just say screw it. It's not that important. But I got under 0.7. What means I'm so close. Again, it's above. Because in this problem, here 0.96 is displayed. Maybe this time is not enough to pass if this doesn't refresh that well. Not sure. I will submit that 5 times. Buffered fast I/O. SSE here would be nice, I would say. Okay, let's check this. Can I paste here? That's a new question. Yes, I can. Now, how to use it? read next, fee read next to read stuff. No, it didn't copy. Fee read next, copy. Why? Is my keyboard broken? Copy. Strange. I was able to copy that big part. Is what fee read next. And here as well. Then for printing, I can just do it like that. At the end, I want to do flash. Earlier, print int, print int -1 that. Now print int answer of I first, space, and answer of I second, new line. Dot, and print int is not there. Okay, so I need int, I need 1 here, and I need to. Good luck, Errichto, I gotta go. Thank you very much for your help as always. See you soon. Okay, see you, Rohit, bye bye. And I need to put a minus here. How to put a minus? They do something like that. This is an array of chars, I guess. Okay, maybe I understand that enough. Plus plus is minus. This was local. Data offset. Yep, it's private. So I need to do like that, I guess. This will also be foo dot. Seems to work. Yeah, I think it's okay. So submit. For print char. Okay, indeed. Print char. Nope. Here. Print char minus. Submitting your code is becoming the bottleneck. Yes, I agree. Maybe I should just open code in some like Visual Studio editor. Where is the accepted? Here is the accepted one. This is easier problem. Maybe I already passed the harder version. I just didn't notice. Your solution is too long? What? The limit is 5000 bytes? Are they serious? I can remove comments if you want. Is that enough? Yes, it is. So the limit is only 5000 characters? Yes, it is. That's crazy. I might be limited by the source size. Okay, I can also remove this pragma. And I can try removing this as well. But it shouldn't matter too much. It can only make things worse. Okay, I don't know how to solve this problem, and it's already too long. It's already taking too much time. So I think I will give up for today. I guess that I'm close. Locally I got something like 0.2 seconds. Maybe it's slightly different on a different input. I don't know how close I am. I thought that if I go below 0.7, then that's fine. Maybe I'm like 1% from getting accepted, maybe not. It's too much for today. Okay, so thank you guys for watching. I will experiment with the admin rights for WSL so that it would be possible to copy files, for example. And next time of boring stream, probably in a week from now, I'm not sure, we'll see. And I will try to do other videos during a week until that, or maybe I will prepare a lecture. So thank you Sarah, thank you Bluefog again for help, and see you next time. Also, don't forget to like the video on YouTube. Bye bye.